I'm really a big fan of thin fonts on dark background. Really great for this kind of conditions. So memory management has an impact on application performance, right? So it has also an impact on application responsiveness and on system requirements. That's a reason why you should care about memory management. At least you should know the basics. And the reason for this session was that every time we have a booth at a conference and I talk to people and I ask them about garbage collection, everybody's like, yes, I know there is garbage collection. So I thought maybe it's a good idea to create a little overview of what's available and how it works in general. So in principle, and I hope you can read it, this is how the memory management is structured in the JVM. So it starts on the left side where we have the stack, right? And the stack is per thread. So and on the stack frame, we save primitives and references to objects. And then that means every thread gets its own stack frame. And if you have something like a stack overflow, that means you run out of memory in the stack frame. And this is growing and shrinking dynamically, so there is no garbage collection in this space. And because it's per thread, it's per se thread safe. And then we have the heap. And in the heap, we store all the objects, right? And the objects where we have the references on the stack, they point to the heap, right? To the objects on the heap. And this needs garbage collection. This is the main focus we talk about today. And then we have the meter space. And the meter space contains all the information that the JVM needs to handle classes. To make it very short, because we are not focusing on this part, only the center part. And if we take a look at code, and now, sorry for the guys in front, but in the back you will see it probably better. So we have this little code example here, where we have some persons, and we have a list of persons. And if we now take that to the stack, then this would be the stack frame for that thread. So each of the persons get a reference on the stack frame, and the list also get a reference here, right? And then we have the heap. And in the heap, the actual objects are allocated. These are the boxes here. And you see the references pointing from the stack to the heap, right? And also to the list. And at the moment, all these objects are live, because they are reachable from the stack. Now, if I set P1 to null, then if you would system out println P1, it would print out null. But it's still reachable because it's in the list, and the list is still live, and the list also points to this object on the heap. So you still can get the result of P1 via the list. People sometimes forget that. So if you null an object, doesn't mean it's not reachable anymore. If you have a reference somewhere in the list or in another collection, it's still live, it's still reachable on the heap. If I then set also the list to null, then it's gone, right? So then only these three center objects are reachable and live, and the other parts are just lying around on the heap, and this is literally garbage. They take up space in the heap, they are not reachable anymore, that means they need garbage collection. So someone has to pick up that stuff and clean it. That's the idea. So it's a form of automatic memory management, and it identifies and reclaims no longer used memory, and it ensures efficient memory utilization. That's the main idea behind it. And it frees users from managing the memory manually. Who did C or C++ here in the room? Who loved it to allocate memory and handle that? It can be a pain in the neck, right? So, and then we have this, garbage collection, and we have different phases in the garbage collection process. So the first phase is we have to identify the live objects. We have to find the objects that are really live, right? That's so-called tracing. If we talk about tracing algorithms, there are different ones, but literally most of them are tracing. So then we have to reclaim these resources that are held by dead objects, the garbage that was lying around, so this is freeing. And then from time to time, we have to move the live objects and compact them somewhere to get a big block of free memory. This is compaction. So these are the three phases, and that leads me to the basic principles of collecting garbage in memory. So first we talk about non-moving collectors. And the reason why they are non-moving, you will see in a little demo. So this is an example for mark and sweep. You probably, who knows mark and sweep or heard of it? Yeah, you should know that. But if you don't know, no problem, I will show you how it works. So we have this matrix, which is our heap, and the gray boxes that you see, this should be objects, right? Or memory places on the heap that can store one object in this case. Very simple idea. When they are referenced, that means when they are live, they will become blue, right? By the allocator. If the allocator allocates memory, it will be blue. After some time, it's not used anymore. Someone just set it to null or whatever. They will become purple. Purple means it's garbage. And then if they have this little red square on the upper left corner, they are marked by the garbage collector for collection. And then if they have a number in it, that just means they survived one garbage collection cycle. So every live object that survived one cycle will increase this counter. That's the idea. So the mark and sweep allocator will start allocating cells in the heap until it runs out of memory, and then it will mark all the live cells. Then it will free the dead cells, and then it will unmark the live cells and will continue. And let's see how that works. So you see, it's probably better to see on the monitors there, but we start collecting memory. And as you can see, hopefully, we have a lot of purple cells there. That means this is dead references, dead objects. Now it's full, we stop the world, we mark the cells, unmark, clean, and then again. So that goes on and on. That's the process of mark and sweep. And you see already the problem. You see it's totally cluttered. Even after we cleaned it up, doesn't mean we have a lot of free space, right? This is a simple example where every object just allocates one cell. If you think about larger objects, for example, if you need an object that has 5 cells, you need 5 free cells in a row. Could be problematic with this collector because it's really fragmented after some time. And who remembers Windows 3.11, where you have to defragment the hard drive? This is exactly what we see here. And exactly this leads us to the next collector, because that's really a problem. It works kind of, but not really good, because we have fragmentation, which is the biggest problem here. That leads me to moving collectors. And moving, you will see the difference. The moving collector, and we talk about mark and compact first. Mark and compact, the algorithm, same thing. You will see exactly the same thing as before, except when we stop the world, we mark all the live objects, we remove the garbage, and then we compact everything, defragmentation, right? So let's start this one. It's the same thing. It will stop a little bit earlier because we need some headroom for the compaction. You will see the last row will be free when it stops. And now it's stop the world, mark, remove, compact. We can start again. Right? You see the advantage. Now, even if we have a large object, we can always allocate memory. Memory allocation is in general faster with this collector because we never have to search for free cells. They are always at the end of the compaction. And that's quite convenient. You see, mark it free, compact, start again. That's the idea of mark and compact. And this collector is also used in the JVM, partly, not everywhere. Okay, that's cool. So now we know we have mark and sweep, mark and compact. Problem with this collector is we need headroom for the compaction, because you can't just copy everything to the left. You have to move stuff to the right, to the left. This whole compaction process, it takes some time. And that's the drawback of this collector. Which leads me to the next one. Totally different approach to the problem. It's a so-called copy collector. And the copy collector looks also different. We have 2 different areas, the so-called from area and the to area. And this will toggle. Every time we do a collection, we toggle the areas. From becomes to and vice versa. And we will start here in the to space, and you see we will collect. It's the same process as before, but instead of cleaning it up, we just copy all the live objects to the 2 space and just wipe out the complete former 2 space. You will see. Mark it, copy, just wipe out. And then we do the same on the right side. Once it's full, we mark it, and then and all the live objects will be copied to the other one, and it will toggle. And again, just wipe out. This is mark and copy. So we don't have to compact, it's automatically compacting, which is a big benefit because compaction takes time. The drawback here is, as you can see easily, first of all, long-living objects will be copied every time. So it doesn't matter. If you have an object that stays for the whole lifetime of your application, it will be copied every time, which is in principle not needed, but this is the way it works. And the other thing is we need twice as much memory on the heap because we have to be prepared that we need the full heap, means we need to copy the whole thing, right? Okay, so this is the mark and copy. This is all basic collection algorithms, and if we combine them, we can get to the generational collector. And this is mark and compact, generational mark and compact. And the idea behind it is that scientists figured out that most objects die young. It's the so-called weak generational hypothesis. And this is not only for Java, this is for all languages. Most of the objects die young, really hard to see, sorry for that. On the left side, you see this peak. These objects are short-living and they die shortly after they have been created. Then we have some medium section, medium-living objects, and then we have really few long-living objects. If we now tailor the whole memory management to this behavior, it could look like this. For the short-living objects, we create the so-called Eden space, right? It's a small space because most of the objects die young, doesn't have to be big. And then for the medium-living objects, we use a copy collector. That's the so-called survivor spaces. And then for the long-living objects, this is a mark and compact collector on the right side. So you see it's a combination of collectors here. And that makes it possible that once objects survive a certain amount of garbage collection cycles, we can just move them to the old generation, the right side. And this one has only be garbage collected when it fills up. And this is usually really big, a huge area. So that means we have the young generation, which is on the left side. It's Eden and the survivor spaces. And we have the old generation, which is on the right side. And if we do a minor collection, we do a collection only in the young generation. And if we do a major collection, it's only in the old. And if we do a full collection, that means we do both. And that sometimes people mess that up. Major collection, full collection. Major collection is only in the old generation. Full collection is both, right? You have to keep that in mind. So, another demo. And this time, if an object survives more than 3 cycles of garbage collection in the young generation, it will be promoted to the old generation. Let's take a look. Okay, here we go. Eden fills up very quickly and will die. A lot of objects will die. We move them over to the survivor space, and then we continue allocating. The whole idea is we can allocate fast, right? Because Eden is small, it will be, the garbage collection won't take long, and surviving objects will be copied to the survivor spaces. They will toggle. Once they reach 3 generations here, they will move or will be promoted to the old generation. And now we will do fast forward. So we move through and you see there's some kind of a wavefront moving through the old generation, right? Because even these objects die at some point. Once this is full, we mark them in the old generation. We compact it. You will see that will happen now, probably, hopefully. Yeah. Mark it, compact, and then we promote all the objects from the young generation. And now we can start from scratch, right? So this is a full collection, which you can imagine takes time. This is what you know as garbage collection pauses, because that's what happened in the older garbage collections in the JVM. So until the heap is not full, everything's fine. When it fills up, suddenly you have to do a full collection. And that makes stop the world, copy everything around, compact, takes some time. Okay, problem here is if we only do a minor collection, right, and we have references from the old to the young one, how do we find them? So on the left side, we have the minor, the young generation, and on the right, we have the old generation. So now this is the stack frames. We do a minor GC, only the left part. We have some references hanging around. And now you see, hopefully, that the left ones are easily to find because they're directly coming from the roots to the young generation. The problem is the red one that comes from the old generation to the young generation, because when we do a minor collection, we can't see it. We don't see this reference, this one here. We can't see, I hope you can see it at all. There is an error going here. And if we do a collection here, this collector doesn't know about this reference. That means if we now just do a collection, this one will be wiped out, even if it's live. So we need a way to figure out what is a live reference that's coming from the old generation and the young one. And for that one, we have a so-called card table. That's also known as the remembered set. So that means the JVM marks this specific cell in the old generation because it has a reference to the young one. And this will be used by the minor collection, and then it knows, oh, there is another one. I have to mark this one too, and then it will work. So it's just if you stumble upon that. And believe me, it will become more complex. This is just very basic scratching the surface. So you don't have to remember all this stuff. Just remember remembered set or card table. This is sometimes quite important. This was all basic. Serial collection, stop the world. Easy, right? So what stop the world means we stop everything in the JVM, we do our collection stuff, and then we start and continue, right? That's easy. What about concurrent collection? So that means the allocator allocates memory. At the same time, the garbage collector is collecting old objects and freeing up memory. So concurrency is hard. And concurrent marking, we just talk about how to mark live objects concurrently, will look like this. So this is concurrent marking. The collector starts marking objects as reachable, and then after it was reachable, it's marked as live. That's how it works. If now suddenly the allocator decides, you know what, this reference, there was a reference here from that one down to this one, and the allocator now decides, you know what, I create a new reference and I delete this one. And at the same time where the collector is marking things live. That means because it passed already this one, this cell, the collector won't detect this one if we don't do anything. That means it continues, right? And then at some point, it will remove this cell because it doesn't know it's a live cell. So that means if everything's marked, then we have the problem. The solution for that is so-called barriers. That's also something that you might hear when you read about garbage collection. There are write barriers and read barriers. And the idea is to keep it as simple as possible. The name says it, right? The read barrier is some piece of code that will always be executed if some other piece of code tries to access a memory cell and read from it. A write barrier does exactly the same, only if you write to the cell. Right? That's the two kinds of barriers. And you have to be careful with read barriers because reading in comparison to writing happens, I think 80% is reading and 20% is writing of objects. So if you create a read barrier, it has to be very performant. Otherwise, it will drag down the performance of the whole system. That's the problem. They will be used to synchronize between the allocator and the collector. And also, if you have this intergenerational, that means from young to old, from old to young references. Read barriers are usually more expensive. Same example. So we go ahead, we mark the stuff. This is reachable. You see there's still the reference. We mark the next one as reachable. OK. And we add write barriers everywhere. This will be added automatically by the JVM. And now the allocator decides to remove this. Same thing as we saw before. But when he does it now, the write barrier will kick in. And in this case, it says every reference that was removed will automatically be marked as reachable. Right? This is just as an example here. And then that means this lower left circle will be marked, and then we have a so-called remarking phase. Until the collector is done with all the marking, it will do a remarking. And the remarking will only find these things that have been marked by the write barriers. That's the idea. And with this, you can make sure that all of this stuff will be found and marked as live. Very simple example, as I said. This is also called snapshot at the beginning, if you stumble upon this, this thing. So this is concurrent marking. Concurrent copying is the next problem, because we saw we have this compaction thing, right? Where our copy collector, we move objects around. And remember, we have references coming from the stack to the object header. So if we move the object, we have to update the reference pointing to the new address, right? So that means if we have stopped the world, this is our object, we have the stack, we have the references pointing to the header. We stop the world, we can just copy everything to a new position. We update using a forwarding pointer, we update all the references in the header to the new position, and once we are done, we remove the object and continue. Easy peasy, stop the world. If we don't stop the world, then it looks like this. We have an object, we copy it, we don't stop the world. That means suddenly this object is also accessible for all the threads. And now both objects are accessible at the same time. And that leads to the fact that threads can now write to both objects, and they do, right? So they write in one object, the other thread writes in this one, which is the correct one. How to figure that out? So we need a mechanism to mark somehow that as long as not every reference has been moved over to the new one, the old one is still the one you have to write to. And for this thing, there is one solution. There are multiple ones, but one is, for example, the so-called Brooks pointer. And the idea is, before we do the copy, we install a forwarding pointer in the object that points to itself, to the same header. Now, we can copy the whole object to a new position, and because the header is not visible now, right? So the JVM doesn't know, and also threads doesn't know about this object now. They only know this one. And nobody knows about the copy, and then we just move this forwarding pointer to this header. And from that moment on, we can update all the references. And if now some thread is writing to the left object, the forwarding header will point it to this one. And others will directly point to this one as soon as the references have been updated. I know it's complex. It gets more complex, believe me. This is easy peasy part. Once this is done, we can remove the left thing, everything's fine again. This is concurrent copying, which is used in lots of collectors. So quite interesting how that works. That was a so-called Brooks pointer. There are also other mechanisms to do that. If we now take a look at the collectors that we have in the JVM, we start with the serial one, which is the oldest one. And I try, because I started the presentation with 270 slides, right? It doesn't work for this kind of setup. So I had to strip it down. This is already 176 slides. And I have to compress it. So that's the reason for this overview. Usually I'm not a big fan of this, but that was the only way how to do it. So you choose it if you have a single core system with a small heap. Small heap means smaller than 4 gigabytes. And if you don't have any pause time requirements, then you choose the serial one. So usually it's a single-threaded application, development environments, microservices on small nodes. Nice. With this one, it will automatically be selected by the JVM if you don't select a garbage collector, and the memory is less than 1.8 gigabytes, or if you just have one CPU. The JVM will decide this is the exact right garbage collector for you. Even if you think you get G1, you get this one, right? If you don't specify a specific garbage collector. Okay, and it's not a bad garbage collector, by the way, right? So it's just, you have to know how it works. Then we have the parallel garbage collector. This is in principle the same thing as the serial. The difference here is you have to think about, you have 10 threads working on your application, and then you stop the world. Then you have one thread doing the garbage collection. This is serial. And then you continue with your 10 threads for the application. The parallel collector works a little bit differently. We have 10 threads for the application. We stop the world. Then you use 10 threads for the garbage collection. And then you continue with the 10 threads for the application. This is the reason why this is called the throughput collector, because the throughput is the highest of all the collectors. Even of the newest one, ZGC, has not that much or that high throughput as the parallel GC. Throughput means it's the relation between time you spend in garbage collection versus time you spend in the application. And this is the best thing you can do if you would like to have high throughput. This is very good for batch processing, scientific computing, or data analysis. It was the default collector from JDK 5 to 7. By the way, who's using JDK 8 in production here? Nobody. Are you sure? You heard what Vinicius said. Amazon uses a lot of JDK 8. Who's using JDK? Oh, maybe below JDK 8. Someone on 6 and 7? Not? OK. So who's using 11? Why not 17? Who's using 17? OK. 21? Some fearless people, 22? 23, early access? No? OK. Just joking. And then we have the CMS collector, concurrent mark and sweep. This is in principle the same as I showed you with the generational collector that we saw, but this is a concurrent mark. But this is exactly how it looks like. We have these different areas in the heap. And this is deprecated. So that was deprecated with JDK 9, and it was removed from the JDK in JDK 14. That means if you're on 17, you can't even select it with this command line switch. You will get an exception. It's not there. So you can choose it if the response time is more important than the throughput. So this is not really the throughput collector, right? And the pause time must be shorter than 1 second. Then this was a good collector. And it was good for web application, medium-sized enterprise systems, and so on. But it had some problems, which was the reason for a new garbage collector. And that was, like I said, deprecated in JDK 9, removed from JDK 14, and the successor of that is G1, garbage first. And this is the default collector at the moment. So if you use Java and you don't specify garbage collector, this is the one you get, right? Oh, who's using Samaru or OpenJ9? Nobody? That's good, because this only applies to OpenJDK. OpenJ9 has different garbage collectors. So they behave similar, but they have different names, and they work also differently, because OpenJ9 has a different JVM implementation from IBM. This collector is different. This is the so-called region-based collector. So we saw that Eden space, survivor spaces, and then we have the old generation. This is different. If this is the heap, then we have regions, and you see on the left side, the region size depends on the heap size that you specify, with -XMX, for example. So if it's, for example, smaller than 4 gigabytes, the region is 1 megabyte, right? If it's larger than 64 gigabytes, then it's 32 megabytes, and it can't be larger than that. It can grow dynamically, but it can't shrink. So this is 32 megabytes is the largest region size you can get in G1. And the idea is you start allocating in a so-called Eden region, which, let's say, is 32 megabytes here. And then you continue with that. If this one is full, you just grab another one, and so on. And there is some ratio, like 5 to 60%, that really depends, should be young generation of the whole heap. So that means you can allocate for some time. And then at one point, we reach this 5 or 60%, whatever. And then we have to do a collection. So now we have to find the regions with most of the garbage in it. Most of the garbage means the less amount of live objects. And the reason for that is, if we just have a few live objects, we just have a few objects to copy, right? So the it's way better for the performance if you just have to copy a few things instead of copying all the stuff. That's the reason why garbage first. The regions with the biggest garbage will be collected first. So we take, for example, these two regions, and then we copy them in a survivor space, because all the live objects from these regions survive the garbage collection. We don't have these two survivor spaces, we just have one. And then we continue, it starts looking like that, and at some point, again, we copy some stuff to the survivor space is full, then we have to promote stuff to the old generation, which is called the to-nerd space, or to-nerd region in this case. And this is how it works. Then we remove the survivor space, and so on and so on. So this is, and then in the end, the whole heap looks like that. The big advantage is we can really choose freely these regions. There's also this humongous space, right? Humongous region. This is if a region the size is larger than half of the region size of the object, then it gets a humongous region for this one. And this won't be copied. This is more or less directly to nerd space, right? But it's a specific one. So it doesn't have to go through Eden, Survivor, and so on. Okay, so this is, you see the difference. This is not the stuff that I showed you in the beginning with the demos. This looks totally different. This is a region-based collector. And all of the new collectors are like this. None of them is like the other ones that I showed you in the beginning. So, as already mentioned, this is the successor of the CMS collector. Response time is more important than throughput. It's very much the same as with the CMS, right? Pause time must be kept shorter than 1 second, then this is a good collector. For mixed workloads, even large-sized enterprise systems, one question for you. Who is actively choosing a garbage collector for his application or service here in the room? Oh, that's what I thought. Most of you just go with the default, which is this one, which is fine. It's a good collector. It's just interesting that we have all these collectors, but most of the people just go with the default. That means the JVM team did a good job, right? Because it seems to work. Okay, this is the default collector from JDK 9 onwards. So even today, it will change in the future. And that leads me to Epsilon. Who knows Epsilon? Someone ever heard about that? One? Yeah, it's an interesting collector. It's the no collection collector. It doesn't do anything. There is no garbage collection here. Does it make sense? It makes sense for some specific use cases. For example, if you would like to test your application performance, pure code performance, and you use a garbage collector, then always the garbage collector will be part of the measurement, right? Because you have no influence on when the garbage collection will happen. If you would like to get rid of the garbage collection at all, you have to use this one. Problem here is, if it's full, the heap, it's full. Right? That means if you have no idea how much memory your application is using, you will run into a lot of out-of-memory exceptions. So that's the drawback with this thing. You don't have any garbage collection, but you need to know how much memory you use. Also, if you only do testing. This is also useful if you really need the last drop of latency or throughput, because if you don't have any garbage collection, you can't go better than this, right? But as I said, you need to know your application. Anyway, if you choose a garbage collector, first of all, measure your application. You need to know your code, how it behaves, and then you can choose the right collector. Just don't trust anybody who says, Netflix is using this one, we use it too, yay. Yeah, we saw that with microservices. Now everybody's using microservices. It's only in builds of OpenJDK, so OpenJ9 doesn't have anything like this. So, but as we saw, nobody uses OpenJ9 here anyway. Next one, Shenandoah. Who knows that one? Oh, a few more. Probably the Red Hat people here. Because this collector was created by Red Hat. And it's the first of the publicly available new collectors, I would say. So it's still region-based, and you can choose it if your response time has high priority, right? You need a very low response times. Responsive application, and this is a very good collector. It's also good for very large heaps and predictable response times. So I think the limit is 10 milliseconds, if I remember right. So they tell you that garbage collection won't take longer than 10 milliseconds. That's guaranteed. That's good, right? This is a concurrent collector. If we think about it, first of all, it sounds great, right? So it runs at the same time when the application is running. But what does it really mean? That means if you have 10 threads, to keep the same example, running for your application, right? So then the 10 threads now will also be used for garbage collection at the same time. That means you might have 8 threads for your application, and 2 threads will always doing garbage collection. What does it mean for performance? It will be lower than with the other collectors. That's something you have to keep in mind. So performance will always drop if you do concurrent collection. And the reason is obvious. So this is good for latency-sensitive applications, large-scale systems, highly concurrent applications. This is a fully concurrent collector, but it's not generational. It just has one generation. At the moment, I'm not sure if Roman is working on a generational version. I think there have been plans, but never made it to OpenJDK yet. So another thing is, this is not available in Oracle JDK. Who's using Oracle JDK here? I don't. Oh yeah, one, Alina. but this is GraalVM. This is a little bit different. I mean the pure Oracle JDK, probably because Red Hat invented it. Oracle don't support it. But it is in OpenJDK. So if you use OpenJDK, you can use it. So it's no problem. You have a little bit reduced throughput, and it makes use of this barrier concept. I will come to that. And it will be complex, believe me. Then we have ZGC. And this is wrong. The Z doesn't stand for 0. It's just, but yeah, it's ZGC. That's the latest and greatest garbage collector that we have in OpenJDK. Again, it's a region-based collector. So we have young generation, old generation. We start collecting stuff allocating stuff in the young generation. When they get old enough, when they age, they survive garbage collection cycles, they will be promoted to the old generation. We don't have survivor spaces here, right? We only have young and old. And it's not really 2 separate spaces. It's mixed up in one big space, so it looks like this, more or less. That is very much simplified. OK. How does it work? I will come to that in a second. This is even faster than Shenandoah, so they can go below 10 milliseconds easily with garbage collection cycles. This is a generational collector, which is always good for performance if you have generational. Because the problem if you have non-generational, that means just one generation, that means you fill up everything, then you have to clean up everything. You fill up everything, clean it up. So if you do generational, you can allocate and then promote stuff. And then after some time, you have to also do the collection in the old generation. So this is usually for performance reasons. Generational collectors are always better than non-generational ones. So this is for very large heaps. And if I say very large, I talk about terabytes here, right? And then still with this very low pause times. So yes, there are still something like stop the world pause times, but they are so small that you can ignore them. It's maybe 3 milliseconds. This is more or less OK for most of the applications. So this is for low latency sensitive applications, large-scale systems, highly concurrent applications. And it will become the default collector in the future. So that I don't know from which JDK on, maybe 23, this will be the default collector for you. And everybody who's a Netflix fan, yes, you will be like Netflix because they use it too, right? And they made some tests, and they figured out that they got a drop of 3% in performance by using ZGC in their application. Doesn't mean it's your application, right? Keep that in mind. You are not Netflix. So yeah, the non-generational version will be deprecated. So just, by the way, I'm a big Netflix fan, even if it doesn't sound like. Then that leads me to the last one in the list, which is our own collector, which is C4. And the reason why I didn't really spend a lot of time in the ZGC is that ZGC is more or less a copy of this one. And we did that already 10 years ago. So, and it's very much the same. The non-generational ZGC is exactly the same algorithm that we use in C4. And this is part of the Azul Zing JVM. And it makes use of the loaded value barrier, which is a read barrier. And remember, I told you, you have to be very fast when you do read barriers to keep up the performance. And this also applies for ZGC. If you use it on Linux, use transparent huge pages. The collector really benefits from the performance. And this is also the same for ZGC. That's why I just mentioned it here. So if we have GC threads, hard to see on this one, I hope better on the screens, and they access the root objects or the root frames here, the stack frames, to find live objects, right? So we mark objects by finding new ones, we mark them live, and so on. And now at the same time, the allocator starts allocating an object. How does the collector know that this object now is live? Well, the big trick here with these collectors is that the allocation thread can also mark objects as live. And that's the big difference. And this is done by using the read barrier. So we have the read barrier on each of the memory accesses. As soon as the allocation thread accesses the memory cell, the read barrier will be triggered, and it will mark the cell as live. So the collector doesn't have to. So the collector and the allocator work hand in hand. That's the big difference here, right? So and how it's done, we call it test and jump. And I think in ZGC it's called colored pointers. That's what we call LVB, or loaded value barrier, but it's the same thing. So the only thing we have to do is, in the read barrier, we check, is it a reference, is it live, and mark it. If it's not live, we will come to that point. And then it will be passed to the garbage collector, right? So this is, and then the garbage collector doesn't have to take care about it. So every cell has just be selected once. You don't have to go in this remarking phase. Oh, this is quite complicated. If we do remapping, that means updating all the references, the other GCs on top and the C4 or ZGC on the bottom, then it's like this. So the first time we copy the header of the object, and what the other garbage collectors do, except ZGC, they create a so-called forwarding pointer, right? And then they have to update all the references. So what we do, and also ZGC, we copy the forwarding information somewhere off heap. And this is always the same place. So what happens then is, once we update it by the read barrier all the references, and if now the application thread tries to access this object, which is not there anymore because it's now here, it does the test and jump. Is it a reference? Yes. Is it live? No. Look it up here and update the references. And then everything is, so again, the allocation thread is also changing and marking things, right? And that helps. And once this is done, we can just remove the original object from the physical memory, exactly at that point, where the other collectors have to first update all the references because the information is in the forwarding header, and this is still in the old location. They have to wait until all the references have been updated. We don't have to, because we have the forwarding information somewhere off heap, and ZGC the same. So this is faster, it's so-called quick release. All right, this is the same as ZGC. It's for low latency systems, large-scale systems. We have, for example, one customer, and they working in high-speed trading. They have a 21 terabyte heap. When I heard that the first time, I was like, what? How big is the machine? I mean, 21 terabyte, and this is only heap. You need more memory, right, for the operating system and so on. So this is only available in Azure Zing. And the difference, the real difference that we have is we don't have the performance problem because we have a different compiler which creates faster code than the one in OpenJDK. That's the reason why the system, when you use Zing, it's still faster as if you would use OpenJDK with ZGC. OK, the question is which one to choose. We have three criteria: throughput, latency, resource usage. Unfortunately, you can only choose two. So either you choose very high throughput and it should very low resource usage. Sorry, latency won't be low, right? So you have to choose this stuff. And to make it easier for you, there's a little chart that can help you figuring out. We have the pause times increasing to the right, and we have the runtime overhead increasing to the left, and then you can choose which might be a good collector for your application. But that means you need to know your application. That's the first thing you need to do. Monitor your application, know the memory consumption, how much performance do you need, and all these things. And then you can choose the right garbage collector. There's an overview, and probably the slides will be provided by the conference, I hope so. Then you can find also some information in one table, which is easier. And with this, I'm done, and we have still 3 minutes left for questions, if there are any. Yes?
What happens when there's the copy of the references and the thread still accesses the old object because it hasn't been forwarded yet, but it changes the value? Hasn't the value been copied already?
The question was, what happens if you copy an object and then the application accesses the old object and try to change it, right? So this, if you talk about the ZGC, for example, this will be prevented by the by the value barriers here, by the read barriers. So you can't write to it until it's copied. So it will do the copy first, and then it will change the value. So they take care about all of these problems. Any other question? Yes. Mm-hmm.
That continues when all the threads are
Yeah.
at that point, right? And I try to correlate with this concept.
Okay. So the question was about read and write barriers.
Yeah, it was about read and write barriers because I try to correlate with normal barriers, but I think
this is a little bit different. So you can think about, like I said, the read and write barriers is a piece of code that will be executed when you try to either read from the memory cell or write to the memory cell. Then first this code will be executed, whatever it is. This is up to you. It's up to the garbage collection creator. It's not like the JVM save points, which is something similar, where you stop all threads. So this is something different, yeah.
Yeah, so then we use, I think the right barriers to know, to make the collector knows that there was a
Yes. Yeah, so the write barriers and read barriers are used to communicate kind of between the collector and the allocator to make sure that everything's in place. Okay, any other question? Yes, over there.
Hello, thank you for your presentation. My question is, considering that I have a microservice, really small one CPU and 1 gig of RAM, by default you use the zero, right? So my question is, in case of really concerns about latency, and I receive many requests, which one is the best?
Okay, the question was, if I have a microservice that's really small, has 1 gigabyte of RAM, and usually you will get the serial collector, and now you think about how can I use another one and make it sense or not? You can try, but I can't really tell you that this is really beneficial, because the other collectors, first of all, most of them need more CPU performance, more memory. So that's the reason why serial is still a good collector for these kind of things. So, and now, unfortunately, we're running out of time. So, yeah, if you have further questions, I will be right at the back of the room, and then we'll be able to answer your questions. Thanks for attending. Need a picture.
Yep. Oh. Okay, hi everyone. I guess I can begin. Hola, bom dia. My name is Alina, and I'm here to talk with you about GraalVM and everything you need to know about GraalVM to build your Java applications using it. So let's go. And first, a quick introduction. So this is my name, and this is my handle on all kinds of social media. You can find me there if you want to ask a question, ask for the slides, ask for the demos. You can do it over there. And I work as a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is this very cool R&D unit at Oracle, where we're doing a lot of R&D and brand new bleeding-edge projects. And what's funny, or like rather interesting, it originates back to the Sun Microsystems days. It used to be Sun Labs, and now it's Oracle Labs. And I love open source and communities. That's why I like coming to places like here, where I get to talk to people in person. And I love both programming and natural languages. I don't speak much Portuguese. I can say maybe like 5, 7 words, but I'm very open to learning more if you would teach me during the breaks. And I'm both a cat and dog person. I have a cat, but if you prefer dogs, don't come after me. I love dogs as well, and I hope that one day I can have a dog as well. And the last thing, this is my photo, so if you want to like ask me something or like follow up, this is how you can find me. Now let's go and talk about GraalVM. So the first thing to keep in mind about GraalVM, because it's a big project, so it can be a bit confusing what it is and what it can do for you and when you should use it. So the number one thing is that it is a JDK, just like you might be using OpenJDK, Oracle JDK, whatever is a JDK of your choice. And GraalVM is a JDK just like that. And we are pretty much not removing anything from the JDK, we are just adding things on top. So one thing that we have added is a new JIT compiler. Like in OpenJDK, you would have C2, and we added the GraalVM JIT compiler, so our own highly optimizing top-tier compiler. And what is interesting is written itself in Java. So a compiler, maybe it's not so intuitive how you can write a compiler in Java, but we did. And then we compiled it ahead of time into a native executable using our own native image to eliminate that possible like warm-up and startup curve. So that is one thing that we added to the JDK. And another thing that we added, I will not talk about it today, but just like for general awareness, is that we added this language implementation framework. So maybe you have heard that GraalVM is kind of a polyglot VM. So you can run JavaScript on it, you can run Python, you can even implement your own language. If you always wanted to have your own language implementation and be a language author yourself, you can do it with GraalVM. We've even seen some pretty interesting projects such as PHP on GraalVM, C# on GraalVM. So if you always wanted to implement something like that, you can totally do it with GraalVM. But the biggest part of it that I want to focus on today is this native image ahead of time compilation. And that is a part that makes GraalVM stand out compared to all other JDKs. So it can do what other JDKs can, just run your Java with the JIT compiler. But what makes GraalVM different is that you can compile applications ahead of time into native executables. And that is something that only GraalVM can do. And also, I like to use this slide to answer this question that people ask me at conferences sometimes, and they want to make it like a tricky question and ask me, when should we not use GraalVM? And my answer is always use GraalVM, but decide for yourself which part works best for you, right? So like you can just do normal JVM stuff if you want to stay on the JVM, and then with the GraalJIT compiler, you can get maybe 10, 50% performance improvement, and that's a very easy migration path where you just download it and set it as your JDK, and you can easily have a bit more performance. Or if you are willing to go like all in with the native image, you can get additional benefits such as startup time, memory usage, etc. And I like also showing this slide because I think it's a beautiful slide design, so I'm just very proud of our team's design skills, But also it highlights all the work that we did over the years to make GraalVM like as useful and helpful and production ready as it is now. So we started working on it back in 2011 when my boss, Thomas Würtinger, joined the Graal team. And I like to highlight a few specific things here. So in 2019, we went with our first GA builds. So until then, we were releasing release candidates. It was not like production ready. But since 2019, we have actually generally available production-grade builds. Then back in 2020, Alibaba moved to using native image in production. And I like showing this because many people think the GraalVM is this, groundbreaking, new, revolutionary technology, maybe a bit scary. And I can definitely see that. But also there are people who have been using it in production for 4 years now and under huge load. You can imagine Alibaba, what kind of traffic they have. And they have been very happy about it. And one more milestone that is dear to my heart. So in 2022, Spring Boot introduced GA support for GraalVM. So since 2022, you can also build kind of production-grade, out-of-the-box supported applications with GraalVM and Spring Boot. And a few words about native image, and then we will see how it works in action. So what native image does for your applications is when you run the native image command and you give it your application, and as input, we are taking bytecode. So you need to give us a jar or your class files. So what we will do is we will look at your application, starting from its main entry point, and we will try to find all the code that we consider reachable. So all the code that your application actually uses to do what it's supposed to be doing. We will analyze the app, and we will find all that code that is actually needed at runtime. And then we will include only that code into this produced native executable. And this applies to the code that you wrote yourself, but also all of your dependencies and even the JDK classes that you are using. So we will analyze the whole project, and then we will include only the things that you are using into the native executable, and we will eliminate everything else. And this way, your application can be run and ready to be used by itself, and it doesn't even need a JVM to run, because everything you might need is already included into this native executable. So this is one part of the story, and often native image, people call it like ahead-of-time compilation, and it is true, but this is not the whole story. So one more thing that we are doing there is heap snapshotting. So as we are discovering and building your application, we are also looking at your heap, and we are looking at which objects are safe to initialize at build time, so that we can take kind of a snapshot of your heap and prepare it for you and include it into this native executable. So you can also start faster with this prepared in advance heap, a version of the heap. And in the end, what you have is a native executable that is also, as you can see here, is platform specific. And then it can run natively on the platform. It doesn't need the JVM to run. And I will talk with you more about benefits of native image, but I would like to start with a demo so we can show it in action. Let's see. So the first thing I want to look at is a Spring application. And there's a bunch of classes here for later on demos. But for the first one, let's focus on the fact that this is a Spring Boot app. And it has this controller over here that exposes an endpoint. So let's go ahead and see if we can run it. And let me just clear this and remove. OK, so I've been saying that GraalVM is a JVM, right? So we can also check what we are running on. And here I'm running on Oracle GraalVM version 23. So this is not even released yet. As you know, Java 23 will be released in September, and GraalVM for JDK 23 will also be released in September along with Java 23. But you already can get early access builds and give it a try and be this like early user. And what is also very cool, if you're using SDK man, can you raise your hands if you're using SDK man? I am as well. I think it's awesome, and everyone should use it. So if you're using SDK man, you can also install just like I did. OK, this is very annoying. How do I make it go away? Cancel. OK, hopefully this will be enough. Let's go back. Yes, what I was saying, if you're using SDK man, you can install GraalVM 2023 early access builds and just use it by default. So that's what I'm doing. So as I said, it is also a JVM, right? So I can just run my Spring application on GraalVM as the JVM. Let's go ahead. It starts, and then it starts in something like 1.1 seconds. And if we go to our endpoint, OK, I think I would need to remap the ports, because this is taking longer than it should have. Let's see, 8080. OK, now it's on. So our endpoint is working as expected, all good. But you know, it's just not particularly exciting, not particularly fun if you ask me. So let's go ahead and compile it to native. And for that, I will do Maven. And I have a bunch of profiles, but I will just do a plain native one. So Maven pnative native compile. All good. So now what will happen is that native image will look at our application, discover what is in the app, and then compile it ahead of time into a native executable. And now, as this build runs, this is the time when some people start losing patience and start complaining to me, Alina, this is taking so long. This is taking longer than building on the JVM. I don't have that kind of patience. And I understand how that can be the case. I also don't have a very big, OK, this is annoying. How do I make it? OK, good. So when we were the build, so this can take a while, especially for a bigger application. But there is a lot to be done. So as I said, it will discover your whole project and will analyze and make this kind of universe, so build an understanding of your complete project ahead of time. And you've seen my app. It's a fairly trivial one. It's maybe 5 classes. But even for that app, we see that there are 17K types. So types are primitives, classes, etc. And where is the analysis part? And even for that smaller application, there are 26K reachable fields. So what I'm saying here, even such a small app, if you're using a framework, if you're using JDK, etc., it is still a fairly big project. And analyzing and compiling and optimizing ahead of time should take some time. And that's also the time that the JVM would spend at runtime, only maybe you wouldn't notice it, because it will distribute those efforts more evenly around the runtime. But with native image, we offer you a trade-off, where you're doing all this work once at build time. And then when you start your application, you don't need to do the things that the JVM will do. So you don't need to load classes. You don't need to profile, interpret, compile, optimize. We offer you a trade-off where you can do it once. And I've been talking for a while, but in the meantime, our build has been complete in 48 seconds. So I think this is not too bad. And now if we go ahead and check out what was the result, we have our demo application compiled just now, and it's 62 megabytes, so not too bad for a self-contained full web application. And also, if I want to, I can reduce this number down even further. So if I care about the packaging size, there are tools that can help me compress it. But I don't care much, so by default, it's 62 megabytes. So let's go ahead and run it. Target demo. And if you remember, the JVM version started in something like 1.1 seconds. Now this one starts in just 46 milliseconds, which is pretty cool. And then when we go back to our endpoint and we update it, we see that it's doing the same thing. So exactly the same job, but it starts much faster. But it's not the only benefit. So let me go back and let me do a quick and dirty, like not benchmarking, but performance measurements, let's say. So let's do this, user bin time -v. And I'm running the same application, only now I will also observe its performance with the time command. So let me go back to the application, and let's emulate a user behavior where we are coming to this endpoint and updating it to see how our application performs. Maybe we have it deployed somewhere as a web server, and it needs to serve those requests that are coming from the users. So as I'm speaking, I'm also updating the page. So let's say I've sent maybe, I don't know, 25, 30 requests in 5, 6 seconds. So let's kill it. And let's take a look at what we see. There is a bunch of things here, but the one that I want to focus on is memory usage. And in this case, it's, well, not exactly, but let's say 73-ish RSS usage, so memory usage at runtime. And I think this is pretty cool for the Spring Web application that is deployed and is serving our user requests. And if I want, I can optimize this number even further down, but I didn't do it. So this is out of the box, how little memory my application is using, even having access to my whole machine and being available to use as much as it needs. And if I wanted to, I could have taken this number even further down. So I think memory usage is a very important metric, and also like the way other people talk about this. So 2 years ago, when Josh Long and James Ward were presenting Spring Native, they did similar measurements, and their application was consuming about 100 megabytes of RAM at runtime. And they talked about it this way. They asked the audience, so how many of you are deploying a Java application and giving it 1 gig of memory? And quite a few people raised their hands, obviously. And they said, so for the memory footprint of that app, you can deploy 10 such applications, or if you want to reduce memory usage, you can deploy 1 and just divide your memory usage by 10. So I think this is pretty cool, and this is achieved by compiling your application ahead of time and not doing all of that work at runtime like JVM is doing. So now we have our basic application, and let's talk about what's in it and how is running on native image different from running on the JVM. So if you have heard one thing about native image and why you might want to use GraalVM at native image, you probably have heard about fast startup, and we also have seen this in the demo now, where your application indeed starts very fast, much faster than on the JVM. And I think we can agree that this is particularly interesting for things like microservices, serverless workloads, maybe even more workloads in the cloud. But what if I have a long-running application that I build and deploy, and then it runs for, I don't know, hours, days, and weeks, and I don't care about startup that much? And I agree with you that startup is not the only metric you could be caring about, but luckily there are more things where native image can be helpful. So the next thing is what I just mentioned in the demo before, is lower memory usage. So you've seen how much less memory native image application is using, because we don't have the JVM at runtime anymore, and we don't need to do all of that overhead and code compilation work at runtime, unlike the JVM does. So this way you can use less memory, and this could be helpful, I think, either in the cloud, where you're paying for your resources that you are using at runtime. So if you can use less memory or for less time, you would pay less. Or even if you have your own infrastructure, you can reduce those infrastructure costs. And also there is I see a lot of this trend lately where people are trying to make our applications more green. So use less memory, less CPU, less electricity even. So if you want to save the planet, save the forest, save the turtles, native image can help you with that as well. Another aspect of native image is predictable performance. We will see it later on, where we will be doing a load testing kind of demo application. And this means that the performance of your application is very even over time. So for the first milliseconds, if you think of peak performance as, let's say, requests per second, and you imagine it as a chart, it will be very stable and very predictable. So again, maybe for cloud deployments, or if you have some SLAs for your users, this can be very beneficial. Whoop, what happened? Go back. And there is another interesting aspect, and that is that native image adds an additional security layer on top of the JVM, because we compile the application ahead of time, and then some things such as serialization, reflection, etc. are possible in native image, but they require additional kind of allow list and awareness and OK from your side to make those things happen. So they eliminate some of the attack vectors that are on the JVM, and we will talk about that in a second. And also, as we have seen, the applications that you will build with native image are more compact. So again, for cloud deployments, where you want to have smaller container images, you want to deploy them faster, you want to scale them more easily, this can be helpful. And now in 2024, if you remember the timeline, now we have support from all the major frameworks and cloud vendors. So if you're building a new Java application now, there is really no reason for you not to be using native image. It's very easy. Now, let's talk about native image and libraries and frameworks and what are the challenges there and how you can make specific libraries and frameworks work with native image. So one thing about native image is that you've seen we are building applications ahead of time, and this needs to happen under a closed world assumption, meaning that everything there is to know about your application needs to be known at build time because the runtime hasn't happened yet. So whatever needs to happen at runtime, there needs to be a way to tell native image that, hey, for example, this method will be called at runtime, or this resource will be loaded at runtime. And this poses a challenge for some more dynamic Java features. So for example, reflection. I don't know if people in the room, can you raise your hand if you have heard that GraalVM doesn't support reflection? OK, quite a few people still a way to go for me. So GraalVM does support reflection, but there are things to know. And the things to know are the following. So some of the more predictable, more kind of trivial and reasonable calls, the reflection API, native image can detect out of the box. So even out of the box, there is like automatic detection mechanism where it will look at your application, it will detect those calls, and it will try to register them automatically. But then if you're doing something more advanced, or maybe more unpredictable, or maybe your library is doing something that it was harder to predict, the way to make this work for native image, so the way to make this information available at build time, is to provide configuration for native image and to tell, hey, those things will be happening at runtime. Can you please build an application that is aware of those features? And can you please include the possibility for this as you are building the app? And this applies to reflection, serialization, resources, proxies. So all that works, but that configuration needs to be provided to native image. And this doesn't necessarily mean that it needs to be coming from you, so you don't need to necessarily write JSON files, but it needs to come from some source, and ideally it will come from a library framework where they will include this config and make those things available to native image without you maybe even realizing what is happening there. And I want to illustrate all that I just said on the example of Spring Boot and how those things happen in Spring Boot. So the way Spring Boot normally works, so let's say before GraalVM, is when you start your application on the JVM and it starts for the first time, it needs to discover your whole application and make sense out of it. And as a part of it, it will pull the configuration from all the different places to build this kind of universe and understanding of your app and pull all the pieces together to build your project, basically, at runtime. So what's interesting, native image is doing pretty much a similar thing. So it will try to explore your application and build the whole project and build the understanding of it and also pull the config and put them all in one place. But Spring Boot does those things normally at runtime, and native image wants to do those things at build time. So they're doing a similar thing, but at a different point in time. And to bridge this gap, there was introduced this new module in Spring Boot called Spring IoT. And this is something that brings those two things together into one place at one time. And what Spring IoT does, it's a new kind of module engine in the Spring framework, and it works as a part of your build process, where it will look at your application, and it will transform it in a way that is kind of easier for native image to understand and make sense out of. And as a part of the transformation process, it will also produce three kinds of things. So it will produce Java source files. For example, for your configuration, it will transform it into a more functional style configuration that is easier for native image to understand. It will produce bytecode for things like proxies. And it will produce so-called hint files. So those are those config files that native image can look at and make those things such as reflection available for your build. So this is a bit complicated, but luckily most of the complexity is hidden from us by Spring IoT, and it just does those things automatically for you. Now, with that being said, let's maybe first look at demos, and then I will talk about how you can make more libraries available to native image. So let's go back here. And I think I want to start with this one. So how many of you have tried using LangChain4j already? OK, some. Tim, obviously. So I have this small, like the most basic LLM application that you can do, where we have our app that just starts and takes an input from a user, and then passes that input to the OpenAI API. And we are using the latest and greatest, so GPT-4o, just released a couple of weeks ago. And then our model and our application will generate a response for us. So let's close all of this, and let's just get to the good part where we already running this in the native mode, and it will work just the same in the JVM mode. So I have my application compiled over here. Again, everything is included over there. So let's go ahead and run it. And we need to ask it something. So let's maybe ask, what is GraalVM? And let's compare with what I said. So people have been promising me that GPT-4o is very precise and very fast. I don't know, maybe it's a network call, but it's my observation that it's not as fast as GPT-4, let's say. But anyway, the response is here, so let's see. It's a high-performance runtime that provides support for multiple languages developed by Oracle. OK, it's nice and precise, I would say. And you can see how the application was fairly fast. There is a network call, so it's kind of hard to interpret the performance. But overall, I would say it's quite fast. And it ran without any, it was built and ran without any config from my side. So it just works with native image, and it's very easy to use this library. So just to make sure that this app is not, like hard-coded any response in it, let's go ahead and ask something else. So maybe we can do, who is Thomas? And let me see that if I got it. View everything. OK, I hope I spelled it right. Let's wait a second. OK, computer scientist, working on the GraalVM project. OK, pretty correct. So I think this is a good illustration of how you can use even like the latest and greatest and popular libraries in the Java ecosystem with GraalVM, and it just works out of the box without any config from your side. But this is not all. I want to show you a couple more demos. So for the longest time, people have been telling me that GraalVM seems like a great fit for CLI apps, because maybe you want your CLI apps to be self-contained, small, fast, etc. And there is this cool library called Pico CLI. I haven't tried it, I'll be honest, but many people said it works really great with GraalVM. I do want to show you something else that I have built, and this is using Spring Shell. So again, I have it already compiled, so we can just run it and see how awesome it is. And this is a Spring Shell application compiled to native image. And what this is, in the essence, it's an implementation of the ls utility that just lists files and directories in the current or whatever user-provided directory. But it's hopefully made more cute, because the original ls is a bit boring, if you ask me. So let's go ahead and run this one. Target native Spring Shell. Yeah. And it comes out of the box with some additional kind of commands and tools, which is pretty cool from the Spring Shell. So it comes with help. There are some built-in commands. And there is my cute ls methods that I wrote myself. So let's run this. And I think you can agree this is a bit more cute than your normal ls. And again, there are some built-in commands, so we can retrieve history. It shows what we just did. And you can also quit this. And yeah, this is how it works. And you can even build more advanced things with GraalVM as well. And again, this is all happening without any config, any manual magic from my end. I want to show you one more application. And everyone is doing AI these days, obviously, so you cannot come to a conference and not show AI. So I brought this Spring AI application, which is a travel recommendation app, where we have an endpoint with a form that we show to a user, and then we are asking them for their preferences for travel, such as country, activity, the mood you're in. And then we are going again to the OpenAI API to provide a destination recommendation for our user. So let's check this one out. AI. And it's called Travel App. So it started in 0.05 seconds. So if we go here to localhost, I mean, the first thing that I want to point out here is, can you please appreciate this beautiful UI that I have wrote myself? It might not look like a lot, but I promise that it looks much better than it did in the first iteration, so I'm very proud of myself. So let's test our application. Again, this is all running in native, and the whole application with everything included is maybe 100 megabytes. So let's say we want to travel to Switzerland, because that's where I live, and the activity that we want to do is, let's say, hiking. I really don't want to, but this is kind of thing you have to do if you live in Switzerland. And let's say we are feeling adventurous. So let's wait and see if we can get a travel recommendation. OK, based on your preferences for Switzerland, hiking, and adventurous mood, I highly recommend visiting Zermatt. It's nestled in the Swiss Alps, blah, blah, blah. OK, I would say this sounds pretty good. But let's test our application some more, and let's see if we can get some more fun recommendations. So let's say we want to travel to Portugal, and we don't need to hike anymore. Maybe we can do cocktails. And let's say we are still feeling adventurous, so where should we go? I recommend visiting the... OK, I see laughs in the audience, so I can only guess that this is a good destination, but also maybe you can educate me afterwards what is this place, because I've been to Portugal many times, and I have no idea, to be honest. But yeah, this is a Spring AI application that you can also build yourself and run in the native image mode. And then if you go out and check the size of our app, so this is my complete compiled application. It's 100 megs. And Spring AI, I believe, just went GA like last week or something. So now you can also build production apps with Spring AI and GraalVM and have the best of both worlds. So yeah, this was about libraries. And now I will show a slightly scary slide, but it's important, so I want to show it. Please bear with me. So I get a lot of those questions. How do I use library X with GraalVM? Or let's say I have an existing project that has a bunch of dependencies, and how do I know that they will work with GraalVM? And the main challenge there are those dynamic Java features that I mentioned, so reflection, serialization, basically anything that happens at runtime. So how you can make it work either in your own user code or in the libraries. And each bullet point here is a solution to that challenge. And you don't need all of them, so each of them is like a separate solution, going from the best case scenario to a scenario that requires a little bit more work from your side. So let's talk about this. So one way how libraries and those dynamic Java features can work with GraalVM is that they can be built out of the box, native image friendly. And we see this more and more lately, where people write applications in a way that maybe don't use reflection that heavily or make it in some way more visible to native image. So ideal case is when the library, framework, etc., is written out of the box in a way that it's easy for native image to understand. And we see more and more such libraries lately. That's a really nice trend. Now, if that is not the case, the next best thing a library or framework can do is they can provide this config for native image in the library itself as they ship it. And for that, I used to show this H2 demo, where I would have a demo that will break because it could not understand how to work with H2 in the native mode. But now it just works. I don't need to show it anymore, because since recently, since a while ago, H2 includes this reflect config within the library itself. So when you are building a project that is using H2, this will be included in the library itself, and it tells native image, hey, please make all those things available for reflection, so you can build your application out of the box without having to configure any of those things for yourself. So this is pretty nice, but the next thing is, let's say you have a library that hasn't yet added support for native image. Maybe they're still working on it, or maybe the maintainers are not convinced just yet that they need to do it. So what is the next best thing you can do? The next best thing that we can do is we created this centralized repo on GitHub, where you would think that, as a user, maybe you have discovered a config for some library. Let's say it was also H2. So why not contribute it to some centralized place, not like Maven Central, but kind of like, so that others who need to use the exact same library can do it and pull this config for you, because why would everyone discover it by yourself? That makes sense. So we have created a centralized repo on GitHub, where you can see a bunch of folders for each project. And this is the place where users, maintainers, authors can contribute config for native image. And then the best part is that this is also integrated with our Maven and Gradle plugins from the GraalVM team. So if you're building an app and you have our plugins added to your project, or maybe you're using a framework that adds those for you, such as, for example, Spring Boot does, all of those projects, if you're using them, our plugins will automatically pull config from display, so this is not something you even need to worry about. So we talked about the first 3 bullets, and this is kind of a happy path, but also I hope that this is the path that most of you will take if you will be using native image, especially, again, if you're building a new project rather than migrating something older to GraalVM. But now let's talk about a case where there is no support yet for GraalVM in the library that you are using. So what can you do then? So the next, and we are getting to this gray area after the orange line. So if you're on a version of a framework that is supporting GraalVM, so let's say for Spring Boot, that would be for Spring Boot 3.0 and higher, when they introduce GraalVM support, what you can do is you can call this module in Spring to programmatically generate hints for native image. So here you can see an example of how this can be happening. So let's say I want to load this file at runtime, and I can call this API to say, hey, can you please register and make this available for me at runtime so that you don't need to write config files, but rather do those things programmatically. And to show you a bit more practically as an example, let's go back to our native Spring Boot app. And I've shown you just the hello controller, but I have a bunch of other things there. So let's say I have this slightly weird reflection call over here, where if this was more predictable, native image could have guessed it out by itself. But this is written in a way to try and outsmart and confuse native image. So this just works in the native image build because I have this class here that implements hints and tells the Spring IoT module, hey, can you please register this reflection call and generate those config files for me so I can do this programmatically. And this applies to configuration for reflection, but also I can have the same thing for the resources. So let's say I want to load, where is this message.xml file from our resources folder. So again, I can call this API and say, hey, can you please generate hints to make this file available and visible to native image as it builds application? And that is a good programmatic way to generate those hints, those config files for native image. Now, let's say you're also on the older version of a framework and there is no support for GraalVM in anything you are working with. So the best thing you can do then is you can use our tracing agent that comes with native image to produce this config for you. And the way this works is you will run your application on the JVM with the agent attached to it, and you would emulate as much as possible your production workload. So let's say I want to load that message.xml file. I would make that call on the JVM with the agent attached to it. And it will look at that call, and it will produce this config file again for me. And this is a semi-automatic way to produce configuration where the agent will do this config for you. And now the last case, I hope you'll never get to this area, but the last case, if you're making just, let's say, one reflection call, and you know exactly what it needs to be, you can also write a JSON file and say, hey, please make this field available as you are building the app. But hopefully, this is a part where you will never get to. So this was maybe a bit more complicated and scary than what we've seen before, but if you want to work with libraries, this is maybe the most useful slide, I would say, in this presentation. OK. And we've seen more demos previously. And this is the page also on our website. So if you want to say, hey, I have this project, and I want to understand if I can run it as a native image, how can I quickly assess if my dependencies will compile OK to native image? And we have this page on the website called Ready for Native Image. And it's a very long community-maintained and contributed list of libraries and frameworks that are known to be continuously testing and integrating with GraalVM. This is a known list. There might be more libraries out there, but this is based on community contributions, a quick way to assess if your library will work with GraalVM. So if you want to assess your project, I would recommend that you go to this page and check out if your library is on the list. And then if it's not, you can still test it, but those are like bulletproof, proven to be working with native image. And I want to say a few words for testing. So we get this question, how is testing different in native image than it is on the JVM? And our recommendation in general for developing applications, but also testing, is that you keep developing your application on the JVM, and then you test for native image specifically in few cases. So one case is if you're introducing a new dependency, you might want to compile to native and make sure that things are still working OK. Also, if you are touching things that you know are sensitive to native image, so reflection, serialization, etc., or in your CI/CD, maybe like once a day, but you don't need to recompile to native all the time as you're developing your application, because normally things would just work. So again, only in cases when you're introducing something new, or if you are touching reflection, serialization, etc., then you would need to test. And when it comes to integration testing, the best thing you can do is look at your framework and what kind of support they offer from the framework itself. So for example, if you're using Micronaut, there is this great module called Micronaut Test Resources that helps you do integration testing, and it works with an native image as well, where they leverage under the hood test containers and help you test, let's say, your database dependency with GraalVM in the native image mode. OK, and let's talk about performance, because I work on a compiler, so I care about performance a lot. And it's a very interesting topic, and a topic where we're getting a lot of questions. So when it comes to peak throughput, how does native image compare to the JVM? And can I have the same peak throughput as I would have on the JVM? And there are a lot of myths and misconceptions in this area, so let's address that. And again, I want to bring a demo to show it in action, and then we will talk about how it works. Let me just close all of this stuff. And as a demo here, we will use a Spring Pet Clinic application, which is a fairly big application that is commonly used for benchmarking. Let me just move this higher up and clean this. And I'm sure you all know this app, but just to show what it does in action, I will already run on the native application, Spring Pet Clinic. And it starts, and it's compiled to native. It's a bigger app, so it takes a while to start, maybe like 200 milliseconds, but still, it started fairly fast, I would say, for a large enterprise-grade Java application. And then if we go to our localhost 8080, you probably know the app, so this is commonly used for benchmarking because it's a good representation of what you would run in production, where you can, I don't know, read data, add data, and it emulates a pet clinic application where you can have owners, pets, visits. So let's maybe not leak my personal address, but let's maybe add another person, blah, blah, blah. And this gets recorded into database, and then I can add pets, add visits, read data, write data. So it's a good kind of standard benchmarking app. OK, this is annoying. Go away. Now, let's benchmark this app. And I'm kind of proud of the benchmarking setup that I have, because this is still not entirely scientific, but almost as scientific as you can benchmark at a conference. It will be complicated, but bear with me, because I'm very proud of this. So we will benchmark this app in the following way. We will first run it on the JVM. And we will use GraalVM as a JVM, but we are turning off the GraalVM compiler. So effectively, this will be a C2 OpenJDK kind of setup. And then we will wait 10 seconds for the JVM to start before we even touch the application. Then we will warm it up for 10 seconds. And then we will do the actual benchmarking run for 20 seconds. So this is the setup. And the actual workload, we will try to emulate a real human behavior by creating new owners, adding pets, reading data, writing data. So this is as close to benchmarking as you can do at a conference. And also, this is running on an isolated cloud instance, so not interfering with my slides or anything. With all that being said and done, let's move this higher up, and let's start benchmarking. So bench JC2. So first, it will run on a JVM OpenJDK-like setup. And now you can see the application is starting. It starts in 5 seconds, but just to be on the safe side, we are giving it 10 seconds to start before we even warm it up. So now we are warming up, sending the actual load, but not measuring yet, because we want to warm up so we can properly benchmark a warmed up JVM. And now we are running the actual benchmarking load. So let's see. 20 seconds, so it will take a while. And we see that in the warm-up run, our JVM ran with, I would say, roughly 500 requests per second. But then the benchmarking run is almost 3x. But the warm-up run was a bit slower, which is obvious, but still one more thing to keep in mind. So now let's do the exact same thing, but in native image, where we will also run our application only in the native image mode. And now I started my app, and we will do the exact same benchmarking, only it's funny because now it seems like nothing is happening, and that is because I'm doing the same as the JVM, so I'm waiting 10 seconds for the application to start. Only the native app doesn't need to wait 10 seconds. We are just waiting 10 seconds as we were waiting for the JVM. So now we are warming up, and now we are exercising the benchmarking load. But we can see that even the warm-up run was already faster than the JVM. So let me scroll away, and let me ask you, so who thinks the native application will be faster than the JVM? OK, some people, but also you realize that I work on GraalVM, so I could have tuned the application to look better than it really is, right? So you didn't have a lot of faith in me, I can tell. But let's see. So the JVM completed the run in 1.5 requests per second. And then native image, its peak throughput at the benchmarking run was 1.1. I would say this is still good because it's very hard to beat the JVM at its own game. So I would say this is comparable performance. But obviously, maybe we're not entirely happy about it. Maybe we want to make it faster. So I have yet another version of this app where I have applied a few additional optimizations. And we will talk about which ones in the second. And let's see if I can make this application faster than it was in this out-of-the-box run. So we will run again for 10, 10, and 20 seconds, but we have applied a few additional performance now. Still not black magic, but some extra performance optimizations. OK, let's go. So this was the warm-up run, and now we are waiting for the actual benchmarking run to be complete. And to recap the numbers, the JVM was 1.4K. Native out of the box was 1.1K. And now the optimized run is 1.7K. So on par and even slightly higher than the JVM. So I will show how it's possible in a second. But before I do, I also want to show one more thing. I talked a lot about resources usage in this presentation and how we want to save the planet, the totals, and everything. So as I was benchmarking the application, I was also recording the resources usage and consumption of each of the apps. So let's compare them side by side. This is the JVM. This is native image out of the box. And this is native image optimized run. And I think this is very interesting, so let's look closer at this. The way to read those charts is that red vertical lines, this is CPU usage, and the horizontal blue lines, this is memory usage of our application. And you've seen they all had the same kind of load that they needed to serve, but they have very different resources consumption. So they were all given 512 megs of memory, but let's look at what we see here. So one thing that we see, the JVM that keeps the CPU quite busy because that is a lot of work to be done when you start the application on the JVM. So it's loading classes, it's profiling, it's compiling, etc. And as it's serving requests, it's also keeping the CPU quite busy, while native image doesn't need that much CPU in either of scenarios. Now, when it comes to memory, you can also see that the JVM went, I would say, almost to 700 megs, especially after the first 30 seconds. And native image is very low, even 200 in the first run, and slightly higher in the second run, where we are using the G1 GC. And the first 10 seconds, when we were just starting our application, you can see that indeed the JVM is very busy for the first 5 seconds because it's starting up. But then native image started, and it's just waiting for us to get it some job to do because it doesn't need that startup time as the JVM does. So those are a few interesting observations here. And in this last run, what is happening here, we have more throughput. You've seen the application was faster, but also we are using a bit more memory. And I think it's a common understanding that if you want to have better throughput, you need to give some more resources, and usually those resources are memory. I see that I only have 3 minutes left, so let me skip to the good part, and show you exactly what I did for the performance of this last app, so you don't think that I cheated in any way. So the way the last app is faster than the previous native image run is this. I did a number of things, and the first and the most powerful optimization that you can do is called profile-guided optimizations. And as you know, the JVM profiles your application as you run. So when you run an application, JVM looks at it, looks at which methods are more often called, which loops are more often executed, and it's specializing specifically for those scenarios. And then if something changes, the JVM can kind of roll back, de-optimize, and optimize again. And you would think native image cannot do it because runtime hasn't happened yet, but you can do PGO, and this works in a way where you would build an instrumented version of your app, then you would run it, and you will apply relevant workloads, and it will observe the application behavior, and it will output a profile file, so kind of the similar thing that JVM does at runtime, but we can embed and consume it at build time to optimize for your application's runtime performance. And this way, we are kind of combining the power of ahead-of-time compilation with having information about runtime available, and we can also specialize, like the JVM does, for what happens at runtime. So if you want to have good peak throughput, this is the best thing you can do for it, but there are a few more things that you can also do. So in case, I mean, this is like a two-step process where you need to do this like instrumented run, observe the application, collect profiles, and then compile again. And it's not always that you have the time and resources to do it. So if you don't do it, you would think that predicting the application's performance and profile is a good task for an ML model, and it is indeed. And if you have an ML model embedded in native image, where if you're not doing this first step, it will look at the application and will say, hey, seems like those parts will be hot, so it makes sense to invest compilation efforts in those parts. It will not give you as good peak performance as user-provided PGO, but it will give you maybe 6, 8 performance improvements out of the box, comparing to not having any profiles. And two more smaller things. Well, G1 is not smaller, but like one more thing that you can do is G1 GC. This is also what we saw in the last performance chart that I showed, where it used a bit more memory, but the peak throughput was much better. So if you want to optimize for peak throughput, you should use G1 GC in native image. And then the last helpful thing is this MARC native flag. And this is telling native image, hey, I will be running my application on the same machine that I'm building, so please optimize for those specific hardware features that you see on this machine. I'm not sending it to users, I'm not redistributing, please optimize for this particular machine, and it will also give you a few performance improvements out of the box. With that, I want to wrap up. I do want to mention two things super quickly. So we are working on this new project called Layered Native Images, where we'll give you a way to compile your dependencies as the base. And then every time you recompile your application, it will be just a matter of seconds, because you will only recompile your user code, the code you actually wrote. And this way, we think we will take compilation step down to just a few seconds. And also in the cloud, you will be able to share those base layers and reduce resources usage in the cloud even further. And we are working on something very cool called GraalOS, which will be a deployment platform for your application, so stay tuned. And if you want to ask a question or if you want to see demos, you can super quickly scan those QR codes, and I will be happy to chat with you. I will give you just a second because I see people are taking pictures. And with that, that was everything that I had for you today. I need to give the stage to the next speaker, but I will be here to answer your questions. Obrigada.
Okay, hello, welcome. Hopefully you can hear me. Welcome to our session, a day in the life of a full-stack Quarkus engineer. My name is Martin Stefanko, and
I'm Andy Demerven.
And together today we are going to learn a thing or two about the Quarkus awesomeness. So, really shortly about ourselves. So, as I said, my name is Martin Stefanko. I work at Red Hat as principal software engineer. I lead the Java user group in Brno in Czech Republic. And most importantly, I'm currently writing my first book called Quarkus in Action. So if you will stick to the end, there will be some nice surprise. And you can find me everywhere online as xstefank.
I'm Andy Dameven, as I said. I'm also principal software engineer at Red Hat. I've been in the Quarkus team for 5 years, and now I'm lead of the Quarkus web team. And you can also find me on internet. Martin, now, what is Quarkus?
So, just really quickly, because I suppose that if you are here, you already heard about Quarkus, or even at least give it a try. But just really quickly, what Quarkus is. Modern native, cloud-native Java framework, really fast, really small memory footprint, very easy compilation to GraalVM natives. So we guarantee that if you just do a command line switch, you will always get into native. We also have something which is very important to note, which is separation of build time and runtime processing. So basically, we are trying to execute as many tasks as we can during your compilation when you do Maven clean package or Gradle build. And basically, we just record the results of operations that we can to the final package artifact, which means that very often these tasks are include like scanning of your classes, building the dependency tree, scanning the configuration, processing the configuration. We are able to do a lot of things at build time and just record the results. That means that we are not including in that artifact stuff that you don't need. So it's faster to start, it's smaller, and it's just easier to work with. And also, you don't need to execute all that operation every time that you start your application as you need to with different frameworks. We also have this concept of extensions, which you will see a lot in this demo, which is basically a pluggable pieces of functionality. And basically, that extension is what is guaranteed that your library, which is integrated through an extension, will always work with everything that we are presenting. OK, yeah, I already mentioned lower memory usage and faster startup. We also focus on very easy steps to cloud deployment. So if you don't really want to write YAML, you don't have to. We also build it around community and standards. So if you are familiar with MicroProfile or Jakarta EE, you can use that in Quarkus. And most importantly, we are focusing on something which is called developer joy, which is this talk about. Andy, what can we build with Quarkus?
Yeah, that's actually a good question. Now that we basically know how it works, so you can do clone native app, obviously. You mentioned that before. You can do really small things like serverless function, microservices, which are a bit bigger, command line app. You can do operator for Kubernetes. Like, there are crazy things you can actually do with Quarkus. You can also do monoliths. I mean, that's fine.
Yeah, but nobody is doing monoliths nowadays, right?
Yeah. And with all the above, those could also be web applications. So you can do a serverless web application with Quarkus. It's so small that works pretty fine, and it can scale from 0 and everything. That works.
Web applications? Really?
Yeah.
Like, I thought that Quarkus is a backend framework, and my front-end skills are 0. He is the front-end guy. He is the full-stack guy. I am just the backend guy. Like, really, web applications with such a framework?
Yeah. But you have a screen before that, shouldn't you?
Oh, well, we lost the screen.
Yeah, we lost the screen. So you can actually scan that QR code. This is a game we prepare for the demo. It uses a lot of Quarkus features, and it's pretty nice, you will see. Nothing malicious. You can really scan it and accept the enable checking.
Maybe we can tell them how the game is called. Because you didn't tell them.
To what, sorry?
What's the name of the game?
Oh, it's 1, 2, 3 Quarkus. Is it what you're looking for? OK. Can you show the screen?
Yeah,
they should start popping up on that screen.
So we are going now into the game screen, so where you can already see yourself.
Yeah.
Wow, that's too many people.
All of you have a bubble at the bottom. OK?
On the bottom, there are yourselves. And now, basically, because Quarkus is a very rocking framework, as you can see on my laptop, we are basically going to shake your phones or tap your phones to rock to the exit, only when there is actually a time to rock. And now you need to stop, because now it's like a stop, you know, like green light, green light, red light, Squid Game. And now again, let's move. And I'm not sure if I'm winning. Oh. And now, again. And I'm actually winning, so I'm going to give up. Go ahead.
Go check your phone. I don't see a lot of people checking here.
Really get to the finish line.
So that was just like a trial run. And later we will have the sound, which makes it feel better, because then you hear the sound when you move, and it stops when you need to stop.
OK, I think that we can finish for now.
Yeah, let's do some fixes in that app, right? And,
OK, so let me get back to slides. So this is what we are going to play today a lot. So what this application is, like, can you explain it to us?
Yeah. So what you saw on that demo, so you have the mobile apps that you get on your phone, the one that you're checking. Yeah, those ones. And you have two services. One is in the runner, the other is the dashboard. They're both on Quarkus. The runner is using an extension named the web bundler on the right side. Yeah, sorry, I did the opposite. That's what we heard. So it's a React app based on Quarkus. And each time you're checking, it will send REST event to Kafka. And it will synchronize through SSE, so that when the game starts, you see it starting and everything. And then you have the dashboard service, which is, this is kind of a funny stack. The screen you see that with the bubble moving, this is actually server-side rendering with HTMX. This is not something you should do normally, but like we tried it. Why not?
You shouldn't do it normally for games, but you can definitely do it normally.
And HTMX SSE is something, so the screen is actually refreshing through HTMX SSE, and if you refresh the dashboard page, it will do server-side rendering. So let's dive a bit deeper. OK. So I mentioned the Quarkus web bundler. This is what is allowing me with Quarkus to do web apps. There are actually two extensions. One is named Quinoa, the other is named the web bundler, depending on what you want to do, but today we'll just focus on that one. So yeah, we did something crazy. We decided to add a bridge on top of npm for your pom.xml. So you can access all npm from Java.
Just to stop a little bit, you are packing JavaScript into Maven.
Yeah.
And you are depending on your JavaScript in Maven and version it.
You might have known WebJar, which was something already, but Maven npm is another bridge, and it more synchronized because it's always up to date. Then you have your project file. So first, in your POM, you add your dependencies, like Bootstrap, jQuery. Then you have your project with your backend. And in your project, you also have this index file, which is using Qt, the Quarkus template engine. And I have that small bundle tag, which is what will actually do the magic. When I will build, it will integrate into the Quarkus build, because in Quarkus, we own the build. So in extension, we can do pretty much what we want. It will take all the JavaScript files from your project, or TypeScript, or CSS, bundle them, remove all dead code, tree checking, and everything, so that in the output, it will serve those nice files that are more for production. And in my template, it will automatically replace with the writing, so that you add your extension, you add your dependency, and you can directly, without any configuration, work on React, work with Bootstrap, work with HTMX. And I think that's good for a backend developer, as well as front-end developer, obviously. But it makes things so easy to use. And it's not that magic. It looks magic, but everything is pretty simple under the hood. OK.
For a backend engineer, I need to only write a single line, bundle, hashtag bundle, and I'm done. So, awesome. OK, but we have this game already, but we are not keeping any state. So actually, what we would like to do in this, and basically session, we would like to live code the database in the backend together with the front-end leaderboard. And I know we took a wrong version of the slides. That's my mistake. He's looking at me badly. But we want to, at the end, give you a chance to actually play this a little bit for like a competition. And actually, I have free codes for my book, which is still in early access, but you can get like all the content already. So the first 3 people in that leaderboard that we will create will get the free ebook. And also for the guys who will be not so lucky, we have a bunch of these awesome stickers that will be rocking on the street. So okay, with that, it's time to get into coding. And I have it here. So I will start, because I want to show you also, before we actually get into like a real database stuff, because that's quite boring or very not so interesting. I want to show you the general flow or how you are working with Quarkus. So we have 2 applications. We have the runners and we have a dashboard. So I will start both of them in dev mode. And I'm using something which is called Quarkus CLI, which is just a wrapper, because if I type it in a Maven project, it will automatically translate to the invocation of Quarkus Maven plugin. If I type it in a Gradle project, it will automatically invoke Gradle task. So it's just better if I'm using multiple different build tools. So I will start also my dashboard. And there is already some magic happening in the background, which you don't see right now. But you remember that dashboard and runners communicate through Kafka together. Of course, I have no idea, of course. When you are preparing for demo, that's always the fun. So at least in the meantime, I can show you that actually, because I just added extension to connect to Kafka, let me start this again, I already, because I started my application in dev mode and I didn't configure any connection to Kafka on purpose, Quarkus started something which we call dev services. So it automatically started Red Panda container, which is very simplified Kafka, and it automatically injected configuration into my application. So you can see here that it injected somewhere, injected config, Kafka bootstrap servers to localhost 55 something, which is 55 something. So it's automatically connected to Kafka. And what is better, my dashboard is also connected to that Kafka, because it's also consuming messages from that. And Quarkus knows that I'm running 2 dev modes on the same machine, and I already started Kafka, so it automatically connects to that.
That's
so my
amazing.
application is already connected, and I didn't need to type anything. OK. So inside this dev mode is interactive. You probably cannot see it, but down here you can press some buttons. And if I press H, it will give me this help message. I will start at the end. You can force restarts, but like you probably already recognize that dev mode means that you can continuously reload your application. I will be not reloading it now. But what is interesting is this instrumentation-based reload, because typically when you reload your application, you will restart it. So you will basically kill the current application and start the new one with the new changes that you did. But with this instrumentation, so if I press H, I will do instrumentation, and I will open this application, and now you need to deal with me, because this will be a little hard to follow. But I have 2 runners down here, and I have my application up here. I basically, if I get into any state, and I will mute it so we don't have the music, if I get into some state, and now I will change my application, and let me change something interesting, and I think it's in game resource. Yes. So I will just make all the runners go a little bit faster. So if I now go into, my application, you will see, well, maybe I will show you here, that actually Quarkus found that I did a change, and it performed a reload of my application through instrumentation. And instrumentation means that it dynamically just changes or modifies the bytecode of the running JVM. So I didn't actually restart my JVM, and this is why I'm continuing where I was before, in the same state, just that zip is now moving a little bit faster.
Yeah, now you know why he is winning and not you.
So if I would not have that instrumentation, where is it? If I disable it now, of course, if I make some change again, so I will make it go even faster, and I go into my application, if I want to do something, it is actually really restarted and I'm losing state. So this instrumentation is a really powerful tool, but of course this is only possible to do on the method level. Anything, even if you just change the method signature, I'm not going to show that, it will automatically restart the application because instrumentation is only possible to some extent. So if you are adding fields, changing methods, adding classes, removing classes, etc., Quarkus will still trigger the full reload. But if you are modifying just method inside the method, then you can keep the state. OK, let's continue. So with that age, what else we have here? Continuous testing. Very interesting feature, because if I just now press R inside this terminal, down here you will see that I start running my tests inside this terminal. It's actually not running it against that application started in dev mode. It will start a new application by default on port 8081, and it will run your tests against that. So it's not interfering with your workflow. But now every time you make a change, so let's go again to 5, you will see that the tests are actually reloaded. Let me put it to the same line so we can see it. And I will actually want to show you a little bit, because currently we have only 2 tests, so I can still rerun them. If I make any change, like even to the test itself, let's fail the test, and I just save the file, you see that it's automatically reloaded. If I fix it, again, I will just save the file. You see that the tests are automatically reloaded. Continuous testing, with every change, it automatically detects that I'm doing something, and it will run the test. Of course, the natural question is, what will happen if I have multiple tests, and they are taking too long to pass, right? So I will really quickly do test name, whatevs, where I will do just assertion on assert equals, what is it? Name utils, names util, get name by ID, which I know that it's zip by default. If I just save it, you see that I'm already running 3 tests, but I only run 2 tests because it detected that I did some changes which are relevant only to some parts of the code. So if I'm changing, basically, if I change that name util, for instance, to not do it correctly, and I save it, you see that it, again, rerun only 2 tests, so it's not running all of them. So it is clever enough to at least detect to some extent what I'm changing, so I'm not rerunning everything every time.
And at some point, shouldn't you start actually, like I know you're a backend developer and you need to explain everything, but could you show that DB and storage, this is?
Yeah, I forgot, oh shit, wrong button. Okay, but, yeah, let me do it here if I already pressed the wrong button. So in Quarkus, you also can add that extension on the command line. So I will be adding extension for Hibernate with the framework called Panache and driver for Postgres, because we will be doing Postgres. And I will start it again in dev mode because I did a mistake. But in general, what that does, it's no magic. It will just modify your POM XML, and it will add the new dependencies. So I have the 2 dependencies here. It also works if you modify the POM XML directly. But in general, this is it. Now I'm already having that functionality. The only thing that I always recommend is to reload your project in IDE, because this is what I forgot to do. But before we move there, well, let's move there. Yeah, I will show some stuff during that. So I wanted to still check what I forgot to do. And yeah, maybe one last feature that I want to show, because like DB will be enough, is this toggling of log levels, which is very useful. So if I press J, you will see that I automatically can toggle between debug, trace, and go back to info, which is also a very useful feature. And also, I want to really quickly show this dev UI. So if I press D inside this terminal, it will open a new, of course, in this one, which it shouldn't. Let's go here. It will open a new browser window where you can basically have graphical insight into your application. Any extension can get any information that they want into this. So for instance, in Arc, in the CDI implementation, dependency injection framework, we can list all the beans that I have inside that application. I can click this button to see the nice graphical representation of how my dependency tree looks. You can also, for instance, change the configuration. So you can filter all the possible configuration values depending on the extensions that you have in your Quarkus application. And if you change it here, like I will darken my console and save it, you will see that it will automatically reload your application and also applies that configuration. And this is actually permanent. Let me change it back because we want to see something. So if I change it back, but I will check actually the configuration file, application properties, you will see that it will remove it. OK, but this is the correct one. I don't have time for this. Come on, Freya. Come on. Yeah, here it is. You need to believe me. I didn't actually know that we updated it, so it will remove it now. So this is new for me. OK, you can also get insight into that continuous testing or to endpoints, that continuous testing that you have here, so you can start it already from here. But really, we are a little bit short on time, so I will now jump to the database integration. So with Panache, it's extremely easy to create your entities, because all I need to do is a new class, entity. We will call it score. And I just need to annotate it as entity, and I need to extend so-called Panache entity class. And this is already a full entity. I actually can write my fields, so we will have name, and we will have int points as public fields. And because we are doing that build time processing, we can actually rewrite your classes during build time. So Quarkus will actually generate, it will make these fields private, it will generate getters and setters during build time, and it will rewrite all accesses to these public fields to use that generated getters and setters in the background. So my code is easier. In the production, you can actually check the generated bytecode, but we will not have time to do it here. You can actually check that it will generate the methods. And also, if you need getters and setters, if there are already there, Quarkus will just use them and not generate new ones. OK, so I have my entity. And the next thing I want to do is my score service, which will be application scope CDI bean. And yeah, for now, let's keep it like this. So I want to persist basically the end result of each game. How can I do that is basically when our game is ending, and we will not bother you with the details, but here I know that the game is over. And I know that if this pref is null, I am actually in the first tick where the game finishes, because here we are also resending some end notification to your phones because network can be unreliable. So I want to just do here basically, and I forgot, of course, to inject my service.
You can see that the code is actually looking like your legacy production app. So we also have those.
Why? It is not. So, and here I will just do score service like persist rank. And we will just call the rank, which is a list of actual runners that basically ended the game. So, and we will create the method. And yeah, this can be void, this will be rank. So I will just check the, if rank is null or empty, we will just return. And if not, then basically for each that will be rank.size, we need to basically persist score, and the score will be for the player, for the current runner, get E. The actual position is I plus 1 because we are starting on 0, and we actually want to also pass the size here, so I could took it to separate variable, but whatever. Because we want to calculate, this will be name, and this will be player size. So, and how we will do this, we will actually just create the entity as normal class, because this is ORM, score name is name, and score points are not player size, but it's player size minus, oh, sorry. Yeah, I see what I did wrong, sorry. This is actually position. Live coding, bear with me. So the name is actually runner.name, and this is player by position, and let's do just times 10, so we have some points. And yeah, that's more or less it. The only thing that I cannot forget is to call persist, which with this panache framework, you don't need any entity manager or something.
You might need a transaction too, right?
Yeah, don't worry, I'm getting there.
Ah, okay.
And the other thing, which Andy will not allow me to forget, I need to, if I'm modifying the database, I actually need to put it into a transaction, so I need a transactional. If I will now basically run my application, but of course, we don't have any way how to verify the results, so I will create my totally perfect UI, which I'm satisfied with, which is called score resource. Score resource, which will be a Jaxares resource, because that's where I'm willing to end. And I will just do here get all, which will be a list of my scores. And basically, with panache, I can just do score and list all as a static method inherited from that panache entity, which will be select star from my score entity. And we can remove this. So if I just change my code, you see that Quarkus already reloaded. So I should already have here HTTP 8079/score, which will be an empty list because we didn't play any game. But if I play a game really quickly, come on. It's too zoomed. Oh, come on. Really quickly, of course. Too much. Really quickly. I should get score persisted inside the database. So I have already the results inside the database. And what else do I want to do? And basically, now I would like to just do some aggregation of the results so we can actually create the leaderboard. And for that, I will just really quickly create. I
think we need to switch.
I need to go a little bit quicker, so I will generate this because it's not so interesting. We will just create a new record to basically just house the actual aggregation of points, and I will just again, through different method, static method on the score entity, I will stream all entities and basically aggregate them by the player name and summing int. And I will just order that and return it to list. So we can actually, and one thing which I forgot, because like I don't want to play that game every time, I will actually create one single file called import SQL in resources. And here I can just put some SQL which will be now automatically, of course, some errors are OK, automatically added to my entity, automatically reloaded with every restart of my dev mode. So basically, I will get that import SQL every time executed when I restart the dev mode, I will get some data at least. And this will be useful for you too.
Yeah, I need the data.
I will just really quickly just demonstrate one last thing. Maybe I will not. You will believe me that if I would just expose it, it will calculate the average, and I will leave the floor to get it actually with some nice colors to Andy. Okay, so if I unplug this.
That's the risky part.
Risky part, go ahead.
This is when you should cross your finger.
I'm not turning my computer off.
Oh, this is the wrong one. There we go.
No, this one.
Yeah. Up. You can talk while I'm
plugging. Now please everyone pray. Okay, question. Yeah, you can definitely invoke the plugin manually. It's just my preference because I'm switching a lot between Gradle and Maven.
Do you have my screen to put on the projector? You don't have it?
Technical difficulties, so...
You don't have it? I can...
We need some jokes for the next time.
Let me put it on the next here.
This is our first time that we are actually speaking in two, so like this was the biggest fear that we had, that this will not work. But what can you do? Technology. Come on.
Oh yeah, here, change this, and mirror, yeah. Okay.
Well, in every case, it works.
Yeah, we're there. Sorry about that.
So we are there.
So let's go on. I have 20 minutes. OK, good. So here I'm using Renard. Renard is for MVC with Quarkus, so model view controller. And here I'm in the controller to show the dashboard. So this is what shows this page. And what I want to do is I want to show the data that he's been storing. So for this, I need to add a new view. So let's add a dashboard view in there. I will copy this.
Like REST endpoint would be enough, right?
So all the app is using HTMX, but let's just forget this for now. And this is the dashboard. Oh, not the template instance, sorry. Up. Dashboard. OK. And here I want a new template, which is also named dashboard. OK, let's create that template here. Here I have all my views, which are HTML files, and I can directly access them through Java, and this gives me type safety, so that you will see later I have auto-completion and type safety in my views.
Also in HTML.
Dashboard, that should work. Oh, and it tells me that it doesn't exist, so let's actually create that file. Up, delete it. For this, I will copy this content. Up. And put it here. OK, so I just took the other view. It's including the main, which contains the header and everything. And here I have what we call a fragment, but you don't really need to care about it for now. This is for HTMX. We will see that later. Here, this will be a page container. Let's call it dashboard container.
But in every case, he is starting exactly where I finished. We just really want to save time on pushing everything throughout the network. So everything is prepared, but we did it like really, he started in where I ended.
Yeah. So now, if normally, if I hit that new page, I should actually see that dashboard page. OK, so
we have dashboard without dashboard.
So I think it's better to have a link rather than doing it manually, right? But first, I want to use a Bootstrap icon. So in my POM, I have the Maven PM Bootstrap dependency, and I can directly use those out of the box. So if I do this, up and go here, not that one, not that one.
Yeah. One other thing which we didn't show, you see that the dev mode is actually failing right now.
So I have a nice icon.
Maybe if you can show the terminal that it's actually failing a lot when he's changing things and saving them mid-flight, but it's still running because it's basically it can survive also if your code is not compilable.
So let's add our link. So let's go back to that page. OK. So here I have my reset button, and I would like a nice button under that one to go to the dashboard. And here I have a small helper so that I can get the URL from my controller without typing it. It's automatic. And I have auto-completion. So I can say, OK, let's go to the dashboard. I can use Bootstrap again. And this is to go to the dashboard. No, I said that. Why I say dashboard? This is leaderboard. Whoa. Yeah, this is bad.
At least you see that you have auto-competition, but you can still make the same mistakes.
And I did that during training, actually, and I thought, let's not do dashboard. This breaks everything. You don't want to do that, but I did. OK, here, this is leaderboard. Up. I need that here. And I need that here too. Here and here. OK, sorry about that. We should be fine. And I guess that also that file needs to be renamed. Yep. Here. This is leaderboard.
So you started doing dashboard like fully.
Yeah. OK, so leaderboard. And here in control, we want to go to the leaderboard. Better. And so here we can write leaderboard and refresh. Did I forget? Yeah, OK. My link appears, and if I click on it, up, it goes to the leaderboard. So yeah, we're fine. Something that would be nice is to use HTMX to actually load that page. so that we don't load the full page, but instead we just load the HTMX part. So for this, it's really easy. I just need to change this to hxget, which will do this through Ajax instead. And I need to specify where I want the page that will be fetched, in which component I want to put it. And I want to put it, I have in the base page, I have something which is name main. So I know it's there. And now, just by doing that, if I click here, let's do it again. Now it's using HTMX, so it will not load the full data. I lied a bit because since I haven't changed yet that method, it's actually loading the full data. But we will see that. So here I will add a small if. If it's an HTMX request, this is detected through the header. I just want to return one part of the screen instead, the full page. So I will get my leaderboard, and I want to return what we call a fragment of it. Up. Yeah. And for this, let's close this to make it a bit nicer. Up. I need to copy.
Maybe can you show it like still that you are what kind of data are you pulling now, so then you can show that you are pulling less?
Sorry, say again.
If you can try to show like how much data are you pulling right now, so
yeah.
you can then show that you are pulling less.
Yeah, you're right, but I already made the change, so you will directly see the right data. So it automatically updated in the browser while he was talking, and I will open the console. Yeah, I know.
This is what I meant.
And let's have a look to this. So now you can see that it's only answered with the content of that element, not the full thing. And you can also see that it didn't update the URL. This part is bad, but I can fix it. OK, here I just need a new. I can do it either through my Java code, through headers, or I can set it here. And this is the exact same link. So we want the leaderboard link. And now if I go here and I click on leaderboard, you can see that I'm on the leaderboard. And if I refresh that page, I'm still on the leaderboard because then it's not an HTMX request anymore, so it loads the full page. OK, and I think that leaderboard is really too much on the top. I would like to add a bit of margin in there. So for this, I can use SCSS out of the box. Like I don't have to do anything. I'm in HTMX. And let's add a bit of margin in there. Margin, 50 px, 0, and save. And that moves in the view.
But
so I can
that didn't reload Quarkus application, right?
Yeah, but the browser is synchronized with the view, and it updates automatically so that I can change those things and develop directly what I want. So what we will do now is to show, that was what we intended. We need to show the actual score. For this, you prepared some data for me, and I will use it. So here in the leaderboard controller, I already have your score service ready, and I have that method that you prepared for me, right? So let's use it.
Actually, this is just the computation that data is actually coming from that import SQL script.
Yeah. So let's use autocompletion. So the good thing is that if I send it to my view will automatically know here that it's using that type. And I will have type checking. So if I use the wrong things in my leaderboard here, it won't work. Here, I want to do a for loop. And I want to iterate on score.
So strongly typed HTML.
And here, I have my score service. No, so the score service is, I could access directly the score service or what I pass through data. In both cases, I have type checking. So I just need to iterate over score point and show the name. So let's save this. And there we go. We already have 2 players here because I have the data that's in the import.sql.
But that's very small.
Let's make it a bit nicer. Yeah, it's very small. Let's fix the fact that it's small a bit later. But already I want to put it on a different row.
Do the front-end magic.
Yeah, that's the one. This is the, I need the position in the rank. For this, if I have a loop with Qt, there is something named count that is automatically injected and that I can use. Let's save. So you can see that now you have the numbers appearing. Now I want to also add the name that we already had before. So score.name. So let's say, I make a mistake here, and I actually save it. You will see that if I refresh here, then it tells me that I made a mistake.
Nice.
But I want the name. And this breaks compilation. So if you change your model and you don't update your template, that will break at build time, which is nice. And here we need the point, which is the last one. Score.points.
And we have points. Yeah,
Nice, right?
That's good.
I didn't add the button to go back. Let's just be the last thing we do here. So I will go here, go back to my dashboard, leaderboard page, and I want a button to go back. So I'm using H6 gate again, and I want that time to go to the index. So URI dashboard, I want to go to the index to go back. Let's directly do the push URL, so at least it's there. URI dashboard, index again. Let's make it nice. Button. And this is go back to the game.
And this is also now taking really the method names from the dashboard class.
And if I go here and I go back to the game, what's going on? Oh yeah, I did. So see, I didn't add the HX target. So instead of putting the data in the right position, it actually put the data in my view. So you can mess things like that, but it's an easy fix. So here I just had to add HX target, and I want it to go to main. And now if I click, that works.
It works.
So I can now navigate between both. Like this. Yeah. Let's play again.
Yeah.
What do you think
We
about
are
that?
waiting
Yeah,
for
that
that.
sounds good. OK. So there we go. Just so you know, this time it will be stored, and we'll do maybe 2 games. So that at least we can be sure that the winner of those books are the right person, right? So
Maybe
people that who own their victory.
I also want a copy of my book.
Yeah, I think I will record them. That's a good idea instead.
I think that everyone is scanned, so you can actually take us on.
OK, let's go. Everyone scan, yeah?
We didn't mention that, but we are running this in OpenShift cluster, which is really just 10 instances of that runner, and dashboard is actually only a single service. I don't know how many people we might have in the room, but I'm very sure that it's going to scale pretty nicely.
So I resetted the game, and you're appearing.
So let's do it.
Did you reset the data?
I probably didn't.
Can I from my UI?
Don't worry about it. We will get the first 2 people that joined will have 20 and 10 points on top. Sorry about it, because I forgot to reset the data.
You still the same people, right? You still have the same name normally. So we have 122 players. That's kind of awesome, right?
Actually, I am the second.
That's cool. OK, so and just I will start. If I start the game, it will record. So let's
rock. Oh, and I'm dead. I wasn't paying attention.
That's a bit like.
Nice. So I think that we already have 3 people. Well, congratulations. We will give you a chance to earn the more points, the better.
Yeah, we will do another game. We have. So
there we are.
Do we keep that one? At some point, it just stops. You will die. But Yeah, let's wait for that one. Who is oh, yeah, I see. This is the guy. So let's.
You could have leave him like above this guy.
So I just killed you. Like, okay, you were too slow. Sorry.
He stole your 10 points now.
So as you can see, this is a lot of event going through Kafka. Like each time you check, this is like maybe 50 requests per second. Then it all goes through Kafka to update that UI. So yeah, that's like kind of a real-world application. Let's see the leaderboard to see where we're at. Okay. Yeah. So for now, who is Ryun? Yeah, good. Who is Uram? Good. And Ots. Okay, so you're in a really good position to win that, but we will do another game, so you're not there yet.
Let's do another game. I really want to win too.
Okay, let's just reset. You didn't plug that it reset the data, right? Yeah. No. Okay, good. So at least we only have the players. Let's wait a few minutes. Everyone should have the turn-in spinner. 3, 2, 1, go.
Somebody is really very, very good, fast. I'm very bad at this. Come on. Oh, yeah. I'm saved.
Yeah, I think we will kill those one.
Yeah, I think we can finish it.
Okay, sorry guys.
Well, that was actually a lot of it.
Yeah, now we have a lot of suspense. You're all back to beginning.
Check the leaderboard, and if it's like similar guys, then I probably can finish, or maybe we can still do one more round.
I think Uram was already here.
One more round?
You still there? Oh, if we want to answer a question, we need to...
Yeah, I think that we can do it.
Yeah?
Like, we can do it in the meantime. If you just mute the music, people can still do one round. So I leave it to you. Who wants another round?
But just...
Who wants questions?
I think those are the winner. Like we made two games. That's all right.
Yeah. Yeah. More people wanted another round.
Oh, okay, okay. Let's do another round there.
It's more fun than questions.
So are you guys ready? I will keep up the sound because I like when it's actually working. Oh, you need the code?
Either shake your phone or just tap it on the running.
So we will share that code so you can have it.
Sorry?
Because each time the music stops, you need to stop checking.
Yeah. Yeah, if the music stops, you need to stop checking. This is like that green light, red light. Like,
yeah. Maybe you saw that TV show. Like, if you were on the TV show, you will not be here anymore. So you have the QR code if you want.
Okay, so final round, and then we will leave a little bit time for questions. So, really quickly, final winners. Oh. I survived. Okay, and we have like 3 people, and I really think that we can finish because like others probably not finish. One more round. Like this final person.
Be careful, that's your last chance to go there. Okay, sorry guys.
Let's stop it, and this is finish. So let's see who is actually winning. Bin?
Oh, but you know that Uram, he was there for like 2. Can you give a bit more? Maybe like we can say the 5 first or something?
Okay, so Uram will get half of the book.
Okay.
Okay, so please, first 5 people come here after the session. I will give you the code if you can show me on your phone that you are in this leaderboard. And we will take some questions now, if there are some.
Yeah.
Can you show that
Yeah.
final slide?
That's what I'm opening. OK.
No questions?
I saw some question from some guy in front during the demo. Maybe he still has those, or maybe it's not relevant anymore? No? OK.
OK, so if there are no questions for the session, here for the people who didn't win, because there is definitely more than 100 people here, you have a 45% discount, which will be valid for the next few days. And please give us a follow on social media, and hopefully you enjoyed the session.
Yeah,
Thank you.
I hope you had fun.
Good job. And anyone that wants to get some stickers of these rocking people, just come
I
here.
also have some you can...
We have a lot of them.
Yeah, and don't hesitate to come to us and ask questions, like if you just feel a bit shy or whatever. We're here for that. OK?
Thank you. OK, put it away so we can put the stickers.
Yeah.
Yeah, definitely. I'm just waiting for him to actually clear the table. Because maybe let's do it like this, because this will be like too many people. So please, take as many as you would like. You can give them if you have like different ones.
Yeah. I have stickers too. So that we can do two. Yeah, why I'm putting it there is because...
You are still on microphone.
Oh, yeah, OK. I need to mute.
Okay, it's test. It's okay. that's a very, very cool presentation, by the way. It's the very first time that I'm introduced in disco mode. Welcome to a session on security and using JDK tools. I'm very happy to be here. It's my first time in Coimbra, and it's a great city. I have heard that it has a very, very old university, but a university with tradition. So I'm honored to be in this city with so much tradition when it comes to education. Allow me to introduce myself. I'm Anna. I'm currently working as a Java developer advocate for Oracle, and I enjoy to share my knowledge about using Java, best practices around using Java tools, and working with Java and containers sometimes, so that you can better understand what are the latest features in Java and how you can better use them in practice at work. You can find me on social media. I'm available on Twitter and on Mastodon, so you can just tag me there and ask me questions. I would love to answer the questions today, but also we can talk after the session. You can ping me on social media, and I can also answer your questions there as best as possible. So let's dive a little into the agenda of today. So what we're going to do, we're going to look into what are the GFR security events. So what are those? How can they help you? Then we're going to look at observing the JDK security properties and what ways we have available nowadays to observe those using JDK tools, which tools, and so on. We're going to move to monitoring the TLS protocol, to analyze a bit the X509 certificates. And of course, the last part is going to need your help a little bit, because we're going to look into monitoring in the cloud and how what we have learned in the previous sections can be applied in the cloud and what we can do with the information there. All of this has the goal so that you can understand how JDK Flight Recorder, JDK Mission Control, and GFR security events can help you with monitoring security of your Java applications so that you can detect potential safety risks. So without further delay, I'd like to talk about the GFR security events. What are they, how they can help you. And I'd like to talk, starting with what GFR and GFR events are. So when you're running your Java applications, your Java application, there are certain events that occur within your JVM and with your application. GFR is the tool that can collect these events and can help you profile your application. So these GFR events, they express both the state of your app, but also the underlying JVM. You can also make your own customized GFR events per your application needs as well. And speaking of profiling, the event data usually is being stored in a .gfr file. And what is common to all these events is that they have some components that can help you understand the data that is held by them, like in the event-specific payload, but also how they connect to each other, because this data is also important for resolving the preceding event. So there's a connection in the GFR file that can help you understand when these events occur and what's the connection between them. But also, there is some metadata information on that describes on how you can interpret these events. So about GFR events, at the moment, I think there are about 150 GFR events, and they're kind of growing. Most of them are related to the JVM, but also can give you details on the stack trace about your application and can get into details about what you're using in your application. Namely, for security, we have a couple of events that can help us with monitoring the underlying security configuration of our Java applications. So we can detect the overall strength of your Java application in regards to what cryptographic standard it is using. Now, JDK 12 introduced 4 JDK Flight Recorder security events, the first 4 in this table. And these 4 are disabled by default in default.gfc and profile.gfc GFR configuration files that are shipped with the JDK. I know that is very little said here in the slides, but you have the asterisk and where these are disabled by default. Now, the first that I want to talk about is the JDK security property modification. Is recording every time that your application is invoking security set property. So every time you're dynamically setting security properties. The JDK TLS handshake is looking into keeping track of the TLS handshake activity, successful TLS handshake activity, by the way. X509 validation is looking into recording details about the X509 certificates that are successfully negotiated in X509 validation. And of course, X509 certificate is just giving you details about which X509 certificates your application is using. Now, these events, there's another column here. It says backported too. So although they were introduced in JDK 12, they're also backported to JDK 8 and JDK 11 update releases. So they were considered important to be available also in the 11 and 8 releases, not just from 12 upwards. You can enable these events by modifying the GFR configuration file or via standard GFR options. And we're going to see in the presentation how we can do that. Now, with JDK 20 release, there were 2 more events announced. Well, we had this GFR security property modification, the JDK security property modification that was telling us when we were dynamically modifying the security properties in our application, right? But it was also good to know what was the initial state of our security properties. So given that, OK, we have a party in the back. That's unexpected. OK, so OK. Cool, folks. That's how security gets fun, with these kind of people enjoying themselves at the security presentation. Now, as I was saying, with JDK 20 release, the JDK initial security properties give us details on what were the security properties that were set statically for our application when we started our application before doing any modifications to that. And of course, this one is probably at the moment the only, for the security events, it's the only one that is enabled by default in the GFR configuration files. Now, another important event is the one about the JDK security provider service event that keeps track about how many times the security providers were invoked, but also which was the order of searching the security providers. Just to give you a little background, there's a little match that is happening when you are requiring a certain algorithm. So that is being searched within the available security providers that you're having in your JDK, and it's being matched according to where that algorithm is being found best. So without further ado, we're going to work with these events throughout the presentation. Let's start with observing JDK security properties and how we can do that as Java developers. Now, there are several ways to observe the initial security properties. The initial security properties, they are statically defined, usually in the security file. And you can find this one in your Java home conf security. So that's where it first takes on. But you can also dynamically set your security properties, as I said, via the Java security methods. So one way to do it as a Java developer, and probably many of you already know this, is to log the initial security properties by using the Java security debug with the value properties. So you're capturing this in your logs. However, as you might know, the logs of your application can grow. You need something that can look into those logs, can extract those properties at some point. So you would need an extra tool to look into this. A much more elegant way would be to record the JDK initial security property GFR event, and when you want to find out where that one is going on. So when you profile your application, you just record this once as it's enabled by default. And you can do that by enabling GFR recording with the exec start file recording. So you can record it since you started your application, when you're launching your application. Or you can do a flight recording by connecting to the running application from JDK mission control. So this is just the beginning. But if there are changes in the security properties, what can we do as developers? Because we always can look into the logs and have that debug property, OK. We said the logs can be verbose, so it can be kind of hard to go throughout time. So to get a better view of the security properties, the JDK security properties, we can have JDK security property modification enabled in GFR configuration. And we can do that with the command of GFR configure, like here in the slide, and just set it to enabled to true. Then you can start a flight recording, even from launching an application, you can do that. If we may have modified this one, sorry. And then we can inspect the recording either with JCMD, which is another JDK tool for sending diagnostic commands, or we can inspect it with JDK mission control. So this is just a little bit in a nutshell, but there are some extra tips when it comes to working with security properties or when it comes to looking into the GFR events. So you can configure more GFR events if you want to connect your GFR security properties with other details that are happening in your JVM by adding an extra space between each setting. So you can use the GFR configure command for more events, not just one. You can also set the JDK security property modification when you're launching the application, so not making your custom profile, but just altering the default and adding a plus there. Or you can set more GFR events when launching the JVM by adding more commas. So you can enhance this by adding more pluses and more commas. Moreover, you can also configure each GFR event from JDK mission control and export that configuration so that you would have your own template, your own GFR configuration without much concern. So how you can do that, you can create a connection to running JVM. And the -XS star flight recording is not mandatory in this case. You just need the GMX connection to that one. In the GMC file, you can do file connection and just select the running JVM and start flight recording. And of course, you can configure each JDK security event when you're going to the next step of this one. And also, you can always inspect the evolution of the captured events in the JDK mission control by going in the event browser, Java Development Kit, and under security, you're always going to find all of these. And just to give you an example on how JDK mission control will look like, for the security, this is just an extract of the, let me see here, of the security property modification. I captured 8 samples of this one. I think, no, 8 events. And in this case, I can look about the details of each of the events in the event browser, but I can also have some very nice graphs to tell me on how many samples occurred versus the events that were captured in each of the sample there, like frame graphs or heat map views. Or we can also look into the dependency views for capturing these events as well. So this is the part for the first 3 of the GFR properties. And now let's move to monitoring the TLS protocol. So we can assess the security properties, which is great. We can know which cryptographic algorithms our application is using. But let's dive a little deeper into looking at the TLS protocol. And first of all, why is TLS important? So for us as developers, TLS is important because it allows us to ensure confidentiality of the data, of the information that we're having in our application and guarding that from unauthorized users that might want to use our application. And that happens thanks to encryption and decryption. Authenticity, meaning that the system can identify the user or the entity that wants to get access to the information before actually communicating that information. And that is done by using certificate authorities and digital certificates. And message integrity. And I have a small problem with the message integrity. In the slide, it's actually message digest over there, not certificate authorities and digital certificates. Minor mistake. To capture the TLS protocol information, as developers probably have used a network protocol analyzer tool like Wireshark. And you attach that tool to the network interface where your JVM is communicating. And then you're looking for the server hello record to determine the TLS version used on a particular socket. But that requires having another tool for looking at the Java application. You have to learn that tool as well. So why not use something available in the JDK? And the developer-friendly way is once again appeal to the logs and log and look in the debug logs and look at the SSL configuration by logging the SSL handshake on javax.net.debug. So that's one way to do it. However, again, logs can grow. You have to discern which one is actually related to the TLS, which one for the security property, and search for specific records. And imagine that this will log every handshake that occurs for your application. So if you have, let's say, 1 million users or 100,000 users, it will log every handshake that occurs for each of those users, or whatever those users are doing when they authenticate and against your application. It's kind of tough to look into. A much nicer way to look into this is by using JDK TLS handshake GFR event to get the essential TLS information. And the way to do this is by switching the JDK TLS handshake options to true in the GFR configuration file, or run the GFR configure command in a terminal window like we have done for the other one, and start a recording while JDK TLS handshake is enabled as well. So there are multiple ways to deal with this one. So there are 3 ways you can do this: either to modify the default configuration, or use GFR configure, or you're using the start file recording and you're just configuring from where you start your application. And we're going to look at this in 2 details via a local demo. So I have my tic-tac-toe application, which obviously what it does, you play tic-tac-toe. You're going to play tic-tac-toe in almost at the end of the session, because I need a little data to prove some things to you. So what my application is having, of course, it wants to authenticate and make sure that only the certain users have access to it. So that's why I'm using a client certificate, which I am checking in a trust store, making sure that, hey, this person is allowed to access this application. Secondly, I want to make sure that I'm also providing secure data to my end users, so I'm using a key store. And in this case, for my key store, because it's running on my local host, I had to configure a little bit of the DNS, and of course, the DNS names if I'm deploying it somewhere else in the cloud. And all what I want to do now, once I have this mutual TLS enabled, I want to monitor this with the JDK tools. So let's look around at this one in practice and find out which TLS version I'm using. So the tic-tac-toe app is pretty straightforward. It's standard Spring Boot application with the tic-tac-toe application here. As I said earlier, let's just make this bigger. I'm using mutual TLS, and I've configured that since I'm using the latest version of Spring Boot. I'm using SSL bundlers to configure that. So what I've done, I've configured my own bundle called Game, where I'm saying, like, hey, I'm going to use a key store and a trust store for doing this against my application. Let me just uncomment the trust store as well. And while you see here the password in clear, I've done it just for the purpose of this demo. Real life would be better to be obfuscated. So I'm just giving all the details of my bundles for my key store and the trust store that my application is using. And of course, I say that, hey, for the client side, you need to authenticate, so you need to provide a certificate. So let's run our application and see what's going on. OK, so I've run my application, and you can see here there are a few things in the log. First of all, when I started my application, I have done it with the Java security properties enabled in the logs just to see them all together. So that's being captured in time in the logs and so on. Let's access my application. Let's find the port. Should be 8443. OK, so let's go here. OK, forgot to say that my certificate is auto-generated, so I have to accept the risk. And of course, is this mutual? Oh, OK. Because this is mutual TLS, it says that, hey, you kind of have to give me, let me see. This is the same. Yeah. You kind of have to give me some certificate to be able to access this endpoint. So let's do that, because I need to authenticate myself as a user. So I need to go to your certificates, import, stores, and I have my certificate of Anna. Very secure password. Probably you saw it earlier as well. Let me reload the app again, and now I'm allowed to go in. So now that I'm allowed to go in, I can also play and so on. However, how can I record the events and the TLS details on this one since I already started my application? Well, the way that I can do that, I can start a recording using JCMD. So let me go to my terminal, and I can say because this is running on my local, first of all, I need to find the LLVM ID of where my application is running. So found it, and now let's run JCMD to start a flight recording. JFR.start. But we also have to give some settings for it. So I want to give some settings to record my TLS events, and I have this in my custom GFR configuration, which is called my profile.jfc. And the name and all of the security events are enabled in this one. So I'm going to say settings, my profile.jfc. Then I need to say a duration for this. I'm going to say, hey, for 60 seconds, record this. And I need to say a location when I want to save this. So I'm going to say tictac.gfr. So let's start it. OK, so the recording has started. OK. Oh, it says I didn't start it correctly. Let me just check. LS. Sorry. Doesn't find my profile.gfc. Settings file. Anyway, we'll see this in a little while. OK. Let me go to a private window so that the TLS is going to be invoked again. OK, so when I'm going here, what my application is saying, hey, you requested access to this location. Do you accept the certificate that the server is giving to you? And it's okay, yes. OK, let me register to play some tic-tac-toe. Save, and now let's sign in again. Play a little bit again. Log out, and so on. So let's check the recording. Yep, there's some data going on in it. So what can I do to investigate this one? If I want to investigate a recording, I can use, once again, the JDK tools, just making sure that I'm using Java 22. And I'm going to use Java home, then GFR, print ---- events. And I just can say, hey, print for me all the TLS events, and has to be hotspot. Didn't print any TLS? Let me try it again. Sorry. OK. So new private localhost 8443. OK, needs to get the certificates. OK. Now let me check. Still nothing? OK, I have another backup for this one, so I'm just going to go and use another recording that I have from back in the day, say tls.gfr. Now, if I am to look into my run configuration, what I said earlier is that if I would use a network protocol analyzer tool or I would use the logs, I would have a record called server hello, right? So let's say server hello. Come on. OK, server hello. So we have a server hello here. And usually what you can do with the logs, you can look into the TLS version that was used here in the server hello part. Now you see that there are two parts. There's server version and there's supported version. Which version of TLS do you think it was used in the end? You can shout the answer. 1.2. Somebody said 1.2. Anybody else is thinking it's 1.3? OK, so I can explain what's with the server version and what's with the selected version. Me as a client, when going into the browser, by default, the browsers are working, and when it comes to web applications, with minimum TLS version 1.2. So when I gave my certificate, I said to the server, hey, I prefer TLS version 1.2 or higher. So the server said, yeah, I support minimum 1.2, that's the server version. But I select to work with 1.3. So in the end, in the handshake, the selected version was 1.3. That's going to be used. So whenever you're inspecting this, it can be like a doubt, hey, which version was used, 1.2 or 1.3? Now, with the events themselves, you don't have the same situation. Because if you're looking at the events and how they were captured, you can see directly the protocol version. So for example, you can see the start time when the TLS handshake event was caught, and directly the TLS version as well. And of course, also the cipher suit that was used in that exchange. That's very important because cipher suits also are getting updated with JDK releases. Sometimes they go into legacy or they're getting disabled because some cryptographic algorithms are not as safe as they used to be. So sometimes it can happen that you're using certificates that are still valid, but they're using cipher suits that aren't unsecured. So you can always get that information in the events and compare it with what is newer in the JDK and what is safe to use nowadays. And also, you can also get, in this case, also the stack trace, like which methods in the JDK were in, which classes and methods in the JDK were involved when the SSL handshake has occurred. Now, because this occurs in my local host, what happens is that the peer host, it's not available because it's my local, but usually if you're using a dedicated deployment, you can see a proper host name. A peer port is -1. Again, on a dedicated instance, you can see the real peer port, which is 8443 in this case. So to recap a bit, when it comes to inspecting TLS handshakes with JCMD and JFR, what you can always do, you can issue the JCMD command to start the recording. Even if your application didn't start with flight recording on, you can always choose to start it with JCMD. You can always inspect the JFR file with all the events using JFR print command. So you don't necessarily need to go to JDK mission control to look at those. And you can get information about the TLS handshake, the version that is being used, the peer host name or the peer port, by printing the events. And this is an event that actually occurred on a server. Now the peer host is, they're a little bit faked. It's not Google, it's google.com, the peer port, and of course the protocol version and others. Now let's move to analyzing X509 certificates. So X509 certificates are also great because they, in my case, from using a certificate, I could say to the server, hey, I am, you should identify me as Anna. I'm allowed to go and play tic-tac-toe. So usually certificates include a public key, have a digital signature, and information of both of the identity associated with the certificate, but also with the issuing certificate authority, the CA. Now, one important aspect of the X509 certificate is the ability of the receiver of these certificates to validate the identity of the certificate presenter. Like in my case, the server could validate my identity that I'm allowed to go and use my application. Now, this trust is established based on a series of fields, like the signature, serial number, version, but also based on the validity period. And many times you've heard that, hey, it's good to always use certificates that are having the proper validity period, never have expired certificates for our web applications. But also it's important to have a proper subject name and a subject public key that has an associated algorithm ID to that. So how can we view certificate details? Now, within the JDK, there is a tool called KeyTool. Probably many of you have used it to look at the K-certs. And you can query certificates in the JDK Trust Store and see what certificates are there. But you can also use KeyTool to query certificates in your own key store, like in my case, keystore.p12 or truststore.p12, by using the KeyTool command there. Another way to look at the certificate's details is once again by looking at the logs and having the Java security debug with the cert path value. So you can have even more verbose if you're adding the -javax.net.debug equals to all, and you capture everything about your application. However, that, once again, generates too much information that's being captured in the logs, and you need something that can help you to disseminate that amount of information. So let's look about using the X509 certificates and the validation JFR events to help us in looking into those details. Now, one way to do this is by going directly in your JFR configuration file and have the settings name to enable, and if you want to check the stack trace as well, you can enable the stack trace too. You can run GFR configure command in your terminal window, so you can once again use GFR configure to have this enabled by default in your default profile that you're using. Or you can enable the GFR events on your application launch. When you're launching your application with the start flight recording, you can also add these events to the enabled. Now, to capturing certificate details with JCMD and GFR, you can use what we did before. So once again, we can run your application with a -xxr flight recording, or you can use an diagnostic command via JCMD and start the recording afterwards. And then you can show the recording details with GFR print. But I said that I want to evolve my application. I want to run it somewhere else, not just on my local host. So the first thing that I want to do for my demo is maybe run it in something that could get me closer to the cloud. So what I did, just let me stop my application. Of course, I went to create a Docker file because that's the easiest thing that I can do for my app. So I went to create my Docker file for my application. And of course, I want to keep my Docker file to use the minimum possible in terms of from image. So I'm not going to use the entire JDK, since my application, even if it's a Spring Boot application, is not using all the modules in the JDK. So I used JDEPs to find out which modules are used by my application. And then I added all the list of the modules to JLink, so I can create my own custom runtime, my own GRE to say so. That is only that minimum that my application needs to run in so-called production. Of course, I compress this as much as possible. That's why I have the compress to zip 9 here. And I'll put this to Java runtime. Now, once I have this, I can use the fact that I have created that layer over there. So I can use the created runtime, make that runtime my own Java home, add it to my path, and of course then add what I need for my application to run. So the tic-tac-toe jar, and of course proper access to my jar. So I'm not running my Docker file with root permissions. I'm just adding a user and a group for that user to make sure that not everybody, that my application doesn't have root permissions when it's running in a container. But also I'm using this port here, 1099. And the reason why I'm doing this is because I'm thinking, hey, I'm going to run my application remote. And I know that in order to access a remote JVM, I would need JMX, so that I can connect to my application and get some information from there. So connect my tools via JMX to my application. OK, so that's why I need the 1099 as well, besides the regular 8443 for my HTTPS application. Now, taking this Docker file, I need an environment to run it, and I could choose between Docker Compose and Kubernetes, and I went for Compose. So what I did for Compose, I know that I have some extra options for my application. I have to provide to my application some details, and I can provide all the details for logging that I did earlier for my local app. But also I can add also the GMX information. And because I need to access my application securely, I need to define how the access to my GMX, to my application is going to be via GMX remote.access. So that's where my GMX user access is being established. And of course, a GMX remote password over there. So without further delay, I needed also to give where the password, where the key stores are, and I've done it with volumes so they can be attached from the outside of my environment, the ports that I need. And of course, maybe in the cloud I'm going to use Prometheus to gather all this information and monitor my application, so I have also attached a Prometheus service in my Compose file. Let's go quickly here, clear this, and say docker compose app -- build. Now let's see how fast the internet is for my case. OK, so it's pretty fast. Good. So to say so, let's go and connect to our application. Let's imagine this is running to a remote host, create a new connection. Local host, I need 1099 to connect to it. And I said I need a user and a password. So I have my user called admin, the very secure password pass1. Test my connection to my running application. It's OK. So next. I can also start the flight recording from here, because I didn't use the -XX start flight recording to profile my application. Call it my recording. And of course, I can go to the template manager, create a new template, and say edit, and say secure app. Just go to security and enable all the details for security here. This time I'm not going to enable the stack trace for the TLS handshake or the certificates. OK. OK, so next, everything is enabled in the security part. And let's finish. So my application recording is starting now. Now let's go again to the private window. Sorry. Remove the certificate just to replicate the same situation as before. And say localhost 8443. Yes, I need to try again to import it. Same password. OK, so now I need to register once again, because it's a new instance. Sign in, and I can play, and so on. So that works in the container as well. So I can replicate the same things that were in my previous environment there. Now let's see how the recording got my details of my certificates. I just need, it's at 93%. It's been recording 1 minute. OK, so now it's downloading all the recording. Going to the event browser, go to the security. I also have my initial security properties. I didn't modify my initial security properties. And for what I've done in my application, I have 351 events catched when it comes to invoking the security providers. So let's go to X509. So what happened with the X509 certificates? First of all, there are 2 validations happening on the server side for my application. So when I provided my certificate to my application, that was validated on the server side, and I have the event thread here. Moreover, I can have the details about my certificate caught as well, so no longer in the logs, but they're all registered here when they were caught in their details. And as I said earlier, you can also have here the details about the signature algorithm, about the certificate ID issuer, and of course the key length that is being used, serial number, subject, and you can also make a difference of which certificate details belongs to the client one and which certificate details belongs to the server one. So the one with the common name Anna is the client certificate. The one with the client with a subject of Internet Widgets PTY-LTD is the one that is on the server side. Validation, so when it's going to be available, and so on. So the same details, more elegantly caught when profiling the application, and no longer searching for them in logs and hoping that they were caught in the logs. So that's another way to do it. But this kind of approach, like me connecting via JMX and providing a user and a password and having JMX enabled and have all these remote access defined, is a practice that was actually common until JDK 16. What happened is that JDK mission control fetches this recording data from the remote JVM and configures this event on the remote machine using something called Flight Recorder MXB. So what happened is that after JDK 16, you can do the same thing that I did earlier by using JavaX management and being server connection. So you don't need necessarily to use the JDK mission control to connect to a remote host and get that event data, that structured data like this. So what are the options of monitoring continuously our application? One way to do this is to monitor this remote host that I have with an ambient server connection. Once again, via JMX, I can use the ambient server connection. I can just do this from another third-party application and look at my application deployed somewhere else, and using a remote recording stream and get the information from this application. Now, this kind of profiling of this kind of monitoring an application is called monitoring an application actively, but out of the process of where those events are actually occurring, but still over the network. So once every second, new data becomes available to read is streamed, and you get it. Now, that's one way to do it. Another way to do it is to stream GFR events actively within process. So this is what I did for my application. When I'm opening the repository of the event stream, and whenever I'm catching, whenever a specific event is being emitted, I am capturing that event, and I am building, in this case, a GOSH with the data from JDK X509 validation for the validation counter. Why the validation counter? Because the validation counter, when the validation of certificates occurs, there can be different lengths for the certificate chain, depending on how many certificates are in the certificate chain for validating. There can be multiple certificates in the chain, so the validation counter can vary. In my case, we're 2, but if, for example, I am using another provider or I'm using another certificate, I can go through a different validation process and the counter can vary, hence the GOSH choice. So this is the active way of just looking into the repository and streaming this into a GOSH. Why a GOSH? So what's the purpose of this? The purpose of this is because I want to evolve my demo setup. So once I'm streaming this, actually, let's go back to this. So I'm streaming this to a specific registry, right? And this registry can be a registry that's available for a monitoring tool like Prometheus, and can get me detail, and I can gather there all the details about these events that are related to my JVM security and correlate them together with other events that are happening with other events or with other monitoring data that I gather on my application. Everything nicely done in volumes, so using Compose. And of course, I can also use these kind of details to get reports and improve my application performance with services that are available in the cloud as well. Now we have a few minutes available, and for the last part, let's play and observe. So scan this and play some tic-tac-toe. There are a few details I need to tell you. You need to accept, despite the warning, because it's a self-signed certificate, so you need to accept it. And I need for you to play. Secondly, I don't have a remember me or a way to reset the password. So if you forget the password that you're using, you have to create a new user with a different username and, of course, a different password. So it's no other functionality. Have fun. And let's do this for a minute. I'm going to watch the counter there and look at this. The reason why you're playing right now is because I want to have data for my events to be captured from my application that's available in the cloud, so that we can look at those events in Prometheus and see what happened with them. Let me get some water as well. Huh? Oh? Yes, you have to... Wait a moment. Yeah, the internet is not the best ever. It's blocked. Okay. That's weird. Oh, I'm sorry. Yes, so the Wi-Fi provider is blocking this. I wasn't expecting it. Okay. Okay. So try with the mobile provider. But I know also that I have issues being on my mobile provider. That's why. Okay. Okay. So that's the thing. What happened is that if you played, you probably created a new user. So I should see an increase in my JDK TLS handshake totals in my last 5 minutes since I gave you the QR. Let's see the graph. So yeah, in the last 5 minutes, most of you have managed to successfully log in the application. And so that's a TLS handshake executed with success, recorded all my events, recording the events and the increase of that, of what happened there. And I can also, so you can see that thanks to streaming the event, I was able to capture it in Prometheus, and I can correlate it with other data, maybe the amount of requests that happened to a specific URL, given that this URL is protected by HTTPS. Let's go back to the presentation. Now, if you want to stay tuned for more, there are a few places where you can get to the written versions of tutorials, including information like the one presented today. And that place is called dev.java. We're also accepting community contributions, meaning contributions from yourselves, writing articles about Java for other Java developers to better understand aspects of Java. We're also welcoming bug submissions, so if you see typos or if you see something that's not expressed correctly, please let us know. There's another website that publishes everything that's new with Java. So every news, every JDK enhancement proposal that is noteworthy for you to be aware of in the upcoming Java release is going to be published on insight.java. There are also great articles on how we can use Java. Recently, my colleague Nikolai Parlok has published great articles on data-oriented programming and how you can take advantage of that in your Java applications. And of course, we have many videos and tutorials on youtube.com/Java. And that's one on security and CAM API. This presentation has some useful links. So the first one, the written version of the presentation is in an article that's available, obviously, on dev.java. But there are also a lot of videos on JFR or on using JDK mission control, the tutorials on how you can better get advantage of the latest versions and latest enhancements with JFR and JDK mission control. So these are new and noteworthy. Secondly, find the code of the tic-tac-toe application. And of course, you can find out how I deployed this in a virtual machine and the code that I used to create my virtual machine, which is also Java-based. And you can find all in the slides here. So I see that the time is out. So this is all the slides with the links and everything that you want to know available there. Thank you. Sorry. And for questions, because there's going to be another speaker coming after me, and I just don't want to take their time to prepare, we can meet after the presentation. I'm gathering my stuff, and we can meet after this and talk more. And we can enjoy also a little bit the weather or outside of the room. Thank you once again for welcoming me. They're great.
Well, hello and welcome everyone. Today's session we're going to tame a wild beast named virtual threads. My name is David, I'm an Oracle ace, which means I like to talk about Java stuff in my free time. And you'll find my Twitter and my website right there. So we have a lot to cover today. And to tame a wild beast, you need to know where it came from. So we're going to talk about some threats from the past. Where did the need for virtual threads come from? And how are we going to solve our concurrency problems prior to Java 21? Then we're going to look into virtual threads. We want to tame this wild beast, so we need to, well, understand its weaknesses, how it works and everything. And because every story needs a happy end, we need to know how we can live happily together with virtual threads using structured concurrency. And at the end, there is some time for a Q&A. So let's start. So this is, I think, the most basic example of how you create a thread inside Java. Who has done something like this before? That's pretty much everyone. That's really nice. So what happens here is that we call the thread class. We pass it a runnable task, which is a runnable. And then we call start. And then the thread will magically perform this operation. So when we call this thread constructor, what happens is that our application is making a call to the operating system and asks it to create a resource for us, to create an actual thread that we can use inside our application. So we have to leave our safe application space, go to the operating system and ask it to create, well, the actual resource, which includes some memory and some CPU time, because nothing is for free. And depending on the operating system you use, it can be almost nothing, but almost up to 1 megabyte for each thread that you create, well, using the thread constructor. So if you're going to do this a lot of time, you're going to reserve or allocate a lot of memory each time that you create a new thread. So how can we use these thread, well, the thread class? So prior to Java 5, we just created a thread for every task that we had. So when you have a task, just create a thread that you want to use right then and there. And this is a very easy way of programming, because every time you have a thread, every time you have a task, you just create a thread right on the spot. And this is very easy, but like I said, every time you have to leave your application, ask the operating system to do something for you, which is kind of a waste of resources and time. So that's where Java 5 comes in. With Java 5, we were encouraged to use the executor services instead of the thread class directly. And what the executor service does is that create an easy-to-use pool for us, and we can just submit tasks into that pool. And then the pool will pick up a task when a thread is ready. But there are also some downsides to this. For example, leaking thread local variables. If you have a task that sets a thread local variable, but forgets to unset it because, well, who's going to remember when you set something? So when this thread is put back inside the pool, it will still have that thread local variable. So the next task running on that same thread will be able to read the thread local variable from a previous task. So that isn't a very nice thing to happen. So you try to avoid that. And of course, blocking methods. Because when you have a task that makes a call to a database, for example, that thread is now blocked outside of the pool. It isn't doing anything useful. It's just waiting. It isn't going to pick up a new task. So while this task is just doing, or this thread is doing nothing, it's just waiting and not doing anything useful. Because remember, those threads are one of the most very expensive resources that we have. And then there is async programming. Async programming tries to solve this, but in my opinion, it is very hard to write. It is very hard to read, especially 2 weeks after you wrote it. And while there are chances that you come in contact with what is called the callback hell, and then you really want to start doing something else. And of course, it is hard to debug, because the Java, the application is really built around stack frames, and when you start doing async programming, that really goes out of the door. So that's why it's not really a preferred way. But the great thing about it, you have all these downsides, but the upside is it makes very good use of the resources. And that's where virtual threads come in. Virtual threads are an alternative implementation of the thread class. So the thread class that we are already familiar with, that isn't going anywhere. We just get a new type that we can use. So to tell them apart, so the threads that we already have from Java 21 or Java 2018 and prior, those threads are still there, but we now call them platform threads because they are managed and scheduled by the platform. But we call these virtual threads because they're managed and scheduled by the by the application itself instead of the operating system. So the great thing about these virtual threads is, like it says, is that the operating system doesn't know anything about them. When you create a virtual thread just inside your application, they are just a concept that lives inside the GVM. And the great thing about this is that now the stack frames of this virtual thread now live inside the heap, which means that we can resize it, or the application can resize it, the memory usage, when needed. Because with a platform thread, we have to allocate the full memory that we may or may not use in advance. So with the platform thread, I have to allocate 1 megabyte if I'm going to use it or not. But with virtual threads, I can just start out with a very small amount of memory, just maybe a few bytes, and if it needs more, I will just allocate more for it on the heap. So the heap is now, or the stack is now resizable. And that's what makes these threads very cheap to create, because you don't need a lot of memory to create a lot of them. So, and how much memory do you need? So I created 2 applications, one that uses virtual threads, and the other one uses the platform threads. And I just started to see when does it start making sense to use virtual threads over platform threads. So if your application doesn't use more than 1,000 threads, then maybe rewriting the whole thing isn't really worth it, because you're only doing it for a small change in memory usage. But if you start looking at the right side of the graph, it's like 1,000 to 10,000 or even 100,000, you really can see that the memory usage starts taking off. And with 100,000 threads, the platform threads just gave out because of an out-of-memory exception. So you could look at it as if the application was very good with its resources, but you don't have an application at all. So the virtual threads are the way to go if you really want to use a lot of threads. So let's see how we can create one of those threads. So, like I said, a virtual thread is just a new implementation of the thread class. So I'm going to create a new virtual thread using the thread class, which has now a new method called startVirtualThread. And what this method does is that I can pass it a runnable. It will immediately start running inside the virtual thread. So I don't have to go start. So let me run this. The computer is thinking. Let me zoom in. So, and as you can see, you have just been greeted by a virtual thread. So in just 2 easy lines of code, well, one if you don't want to do the join, you can just create a virtual thread on the spot. And this is how you are supposed to use them. Just create them right then and there when you need them. So one method is nice, but we also get a new builder method by using off virtual or off platform. With platform, I will create just the threads that we already know, the platform threads. But if I want to create a virtual thread, I just have to use the off virtual. And then I can set things like, for example, the name. So I'm going to call this one VT name. And I can give it a unstarted task. I can also give it a started task, and it will immediately run. But just for the demo effect, I will just go start, and then a join to print something to the console. And if I run it again, it prints hello everyone again, which is really nice. So with Java 5, we are encouraged to use the executor service. So with Java 21, it also got a little update. And is that now the executor services now implement the auto-closable interface, which means that I can use it together with the try statement resource, the try statement. So I can use executor service. I'm going to call this a VTE instead of the new virtual thread per task executor. So what this executor does is that it will create a new virtual thread for every task that I submit to it. So for example, I'm going to create the for loop, and let's create 100,000 threads because that's fun. And just let them sleep for 1 second. In production, you would never try and create threads just to let them sleep for a second, but it's perfect for a demo. So it's going to create 100,000 threads. All of them are going to sleep for 1 second, wake up again, and then the program is over. So the great thing about this try with resource statement is that I don't have to call join or anything. To exit this try, all the threads that I created within it need to be finished, either by exception or successfully. Only then can I exit this try statement. So what happened is that I just created 100,000 threads, and they all slept for 1 second. So how does this work? How do they get time on the machine? Because I'm only running this on a laptop, and I don't have 100,000 cores. So what I just did looks a bit like this. I created a bunch of virtual threads that run on, for example, 4 cores. So let's say that this machine has a 4-core system. So how do these virtual threads map to a core? So these virtual threads, they don't run directly on the machine, but they run on what is called a carrier thread. And a carrier thread is nothing more than just a platform thread designed to execute the tasks of a virtual thread. So a virtual thread doesn't run directly, it runs to a carrier thread. So if I zoom out a little bit, then you can see that these virtual threads that I created, all 100,000 of them, live inside a queue, and they get assigned a virtual thread, or sorry, a carrier thread, and this carrier thread starts running this task. And of course, the carrier thread is just a platform thread that is managed to schedule by the operating system, so all the way down. So these carrier threads will run the work of the virtual threads, but how does it know when to switch, or how do you manage the carrier threads? Yeah. So like I said, you get, I have a 4-core system. So by default, I get 4 carrier threads. But of course, you can change this using the manage carrier threads, using the virtual thread scheduler parallelism parameter. By default, you will get as many as you have cores inside your system. So a 4-core system, you will get 4 carrier threads. But if I change it to 5, then I will have 5 carrier threads by default. So how does a carrier thread know when to switch from one virtual thread to another? And that is done through mounting and unmounting. When a virtual thread is blocked, it will be unmounted from the carrier thread. So the memory, so the stack frames of this virtual thread are copied from this carrier thread back into the heap. So it is really physically taken off the carrier thread. And a new virtual thread will take its place. So from the queue, a new virtual thread is taken, and it will be mounted on the carrier thread. So the stack frames are copied from the heap into the carrier thread. So if you zoom out a little bit, this is the complete cycle, is that they all go back into the queue, and a new one is taken from the queue to run on the carrier thread. So the great thing about this is that while the virtual thread is waiting, it is in a blocked state, it is waiting inside of the queue. It is not blocking the carrier thread, which is a very expensive resource, but it's now just waiting in the background. And that is what makes these virtual threads really great, is that they are very good at waiting, just sleeping, just doing nothing, because they don't run any faster, they just, well, like to sleep. And then just one side note is that the virtual threads, as you can see, they don't always run on the same carrier thread. So it's not guaranteed that your virtual thread will run on the same carrier thread as it did before. So let's switch it up a little bit, because I created a little demo that I have to find the right IntelliJ window. So what I want to show you is something that I found out, is that when virtual threads work and when they don't work, so that we all know that there aren't a silver bullet. So I created a little application. It's just a simple Spring web app, which has two mappings for random pages. So I can have a random page, just generates a page with 100 URLs on it without a delay, so it will return immediately. And I have one URL which will also generate a lot of random URLs on a page, but it will sleep for us just a tiny amount, somewhere between 10 and 200 milliseconds. So it's quite random, so I don't know what it's going to be, but it is going to sleep, and then it will return also some pages. Because, like I said, virtual threads are very good at waiting, and everybody, it is pretty much assumed that virtual threads work very well with I/O-related tasks. So let's see what it does when you try and put it to the max. So I just showed you just the web server. So now I'm going to crawl the web server, the Spring web server that I just showed you. So as a seed, I have this local host, this URL with the delay. And I'm going to use the new virtual thread executor. And I'm going to submit 400. I want it to crawl 400 pages, only then it's done. So let's see how many pages it can do in a second. So let me zoom in a bit. So with virtual threads, I'm able to do 574 or 47 pages a second. And let's see what happens if we try to do this with platform threads. So the threads that we had before. Just to show you, it has the same amount of it uses the same amount of threads as the virtual threads do. So with virtual threads, I will get, I think on the machine, 8 carrier threads. So just to make it equal, I will also create 8 platform threads. So let's see how many pages I can do with the platform threads. It takes a while because it's slower. And it shows me 124, which tells me that the platform threads are a whole lot slower than the virtual threads, which is quite as expected, because I have to go out of my machine, I have to wait a bit for the Spring application to create a result. So let's try and do something else. Let's switch it up, because I have also the other endpoint without a delay. So it should be much faster, right? So here I am doing it with the virtual threads. It gets 836 pages a second. Let's just run it again just to see if maybe it can be a bit quicker. 746 and 840. Okay, so 840, I think that's around the max that we can get. So let's try and do the same thing with the platform threads. And with platform threads, I'm able to get 1,238 pages a second, which means that even though it is an I/O-related task, the virtual threads are underperforming in comparison to the platform threads. So even though the virtual threads are supposed to be quicker because of the whole non-blocking and or the mounting and unmounting and the whole blocking stuff, if you do it, if the blocking doesn't take enough time, let me go back to the presentation. So with the virtual threads, I'm forced every time I make a web request, I have to unmount it and mount something else. Well, the platform threads don't have this, this issue. They can just wait on the spot. But with the GET request that I'm doing every time to this web server, I'm forcing the virtual thread to be blocked, to be unmounted, and to be mounted again. So every time this does take some time. It's not for free. It's just to show you that virtual threads are not a silver bullet. So the virtual threads, they don't always get unmounted. And that's when we say that a virtual thread is pinned. The virtual thread is then pinned to its carrier thread. It can't be taken off. And that's because not every method is ready yet. For example, the synchronize block, the object.wait, or call to native code using something like GNI, causes the virtual thread to block and to be pinned. It says in the title yet because they are working on an issue or to resolve it, but there is an early access build of Java 23, which should resolve this, but they are looking for feedback if the performance is right. So, but if you are using 21, then this is still a blocking and pinning operation. And when a virtual thread is pinned, so the carrier thread then is also blocked, then the application can decide to spawn more carrier threads and to create a max pool size. So for this example, you have the max pool size of 10. Then the application can create that many extra carrier threads. So if I have, by default, I have maybe 4, and then it can go up to 10. So then you can get more carrier threads to just prevent the degradation of performance. And to see if a virtual threads get pinned, you have these two options, this run option or this system property, that you can set, and it will show you a description of when a virtual thread is being pinned. It will show you a little stack trace. In the short description, it will show you just a few lines, but with the full, you will get the full description that is available. I must say that in my experience, the full description is the most helpful, especially if you are working with lots of third-party libraries. Because otherwise you don't know really where to look. So the pitfalls of virtual threads is that you don't want to use them for long, well, not blocking calculations, because like I said, these virtual threads, they are very good at waiting, just doing nothing. So if you're going to put them to the test and make them work very hard, then it's just recommended to use the platform threads. Don't use virtual threads just because like I showed you with the web server scraper, you would say that it's a very good use case, but still, only then it still underperforms to the platform threads in certain situations. So testing really is key, and comparing if it really has a good effect on your application. And of course, old libraries may still use the unsupported methods and still cause a bit of pinning. So that's something to look out for. And like I said, these virtual threads, they aren't any faster because, well, they still run on a carrier thread, which is still a platform thread. So they are just a nice little abstraction to create a bit more threads than you can before. And then just a few design thingies is that you want to create virtual threads right when you need to. You don't want to pull these virtual threads. That's really an anti-pattern. You should just create a virtual thread for every task that you have. There are some code bases where people use a pool of threads to limit access to a resource. But it would be better to just replace that with a lock instead. So, virtual threads are great, but I like structured concurrency way better because it makes dealing with virtual threads a whole lot easier. And because it's quite a new concept, and it also took me a little bit, well, a lot of time to, well, get to know how it really works, I want to start, well, really simple with just this little bit of structured code. And I think everybody, should be able to, well, know what this application does. I have this method A, I run B, then method C, and then I will create some result that I can return to the caller. And the great thing about this structured code is that it tells me exactly what is happening when. So inside the lifetime of method A, I will first call B, I will then call method C, then I have a result that I can return to the caller of method A. And when something happens, I know exactly that I can stop right then and there in a moment. So when method A is running and method B throws an exception, I'm not going to try and call method C because it doesn't make any sense. And I'm not going to try and create a result because I am missing B. And the same goes for if C throws an exception. I'm also not going to try and create a result. I ran B, but yeah, that's just a waste of time, but I can't really do anything about it. So I'm not creating a result. So let's take the same example, but now add threads to this. And then I have, again, the lifetime of A, but B and C run in parallel. So I have C and B running at the same time. And when both of them are ready, I have a result that I can return to the caller. And now the same thing happens. Method B throws an exception. But what happens is that method C just happily continues running. It isn't really bothered that method B throws an exception. Method A also doesn't really care. But when I'm trying to create a result by foo.get, Then I notice, wait, my thread threw an exception, I can't create this result. And then I have to get out of my way and try to stop method C from running. I have to kill that thread in one way or another. So there's really this implicit relationship between these three threads. I have a thread inside C, B, and of course the parent that is running inside that's running A. And of course method C can also throw an exception, but it's a little bit worse. Because now method B is running, I have to wait for it to finish, which can take X amount of time. So the foo.get finally returns, and then I do the bar.get, and I find out, wait, I have waited all this time for B to finish, but I could have stopped way earlier because, well, I can't create the result that I want. So I could have stopped way earlier. And of course, the parent thread could also just, well, stop running, and then I have two threads running inside my system that I need to stop, and I don't know how, I don't really have a reference to them. So good luck, which isn't really nice. Not a great situation to be in. So with restricted concurrency, this tries to resolve it and make this whole relationship between those threads a bit more explicit, so that the next developer knows what you meant when you created the method. So let's see how we can do this in Java. Just zoom in a bit. So the way structured concurrency is implemented in Java is with the structured task scope. The structured task scope, we get two flavors with 21, which is the shutdown on success and the shutdown on failure. And what this is that it are two policies that state when the virtual threads that you created have to stop. So with the shutdown on success, the policy states that I want either I want my virtual threads to stop when the first one has finished. So I only want the quickest result. So I'm going to create in two threads using the scope.fork. And the scope is of the structured task scope.shutdown type, and will return a string. So using the scope, I can fork new virtual threads. They will immediately start running. And they are of the type of virtual, and they will be a virtual thread. So I will create two virtual threads using the fork method. And then I will do a scope.join. And with the scope.join, I'm saying I will wait here until one of the threads has finished. And then I want to continue. So when I run this example, we are going to see which one finished first. And as you can see, the first thread returns the quickest. So if the second thread is finished, the result will be ignored. If it was still running, it will be cancelled. And using the scope reference, scope instance, I can get the result of the thread that finished first. And of course, this also happens inside this try statement. Cool. Scrolling is hard on this resolution. So this is the first structured task scope. So the second one is the shutdown on failure. And the shutdown on failure, so let me make this a bit bigger. And the shutdown on failure policy states that I want to shut down all my virtual threads if one of them throws an exception. So either they all finish successfully, or if one throws an exception, I will just stop. So again, I will create a try with resource statement, create a new scope, this time of the type of shutdown on failure, and I will fork two new virtual threads. And I use the subtask. I believe you can also use the supplier, but the subtask shows you a bit more information about the virtual threads and its status, so I think it's a little bit nicer. Shows you more options. So, and then I have a subtask A and B. And I'm again doing the scope.join, but because we saw that in the last example, I'm going to make it a bit more exciting by using a deadline. So I give the threads, both virtual threads, 10 seconds to finish. And if they don't finish in time, I will just throw an exception. And at the end, I have to throw a failed. And the throw a failed will rethrow the exception that has happened inside one of these threads if one has happened. And then at the end, I will get the results from both threads. So when we run this, you can see that it printed result 1 and 2. So both threads were successful, and they finished within the allocated time of 10 seconds, which is really great. So, but there are some moments where you really want to go, and create one of your own. So you can also create your own structured task scope. So let me show you what I want to do, is that I want to create a criteria scope, because I'm looking for a product. I'm looking for a product that is worth less than 100. So I have 3 search methods really. One that gets a product of 50, one of 300, and one of 200. They all have a little bit of a delay, so I don't know. I don't know is a really big word, but as you can see, the product of 50 will sleep for 0 seconds, 300 will sleep for 10 seconds, and product of 200 will also return immediately. So let's give this one a bit more time. So product 200 will also return. So what I will do is that I have here a structured task scope, or the criteria scope that I created, which extends the structured task scope, and it will return of product. And what you want to do is override the handle on complete method. Every thread, when it finishes, will call a handle on complete method. And then using the subtask parameter, I can check the state, see if it was successful, because I'm only interested in threads that really find the result and not the failing ones. And if it was successful, I want to check if the price is less than 100. If I found my product, I'm going to save it for later and shut down. So the threads that are still running will be shut down, and the join can continue, and a simple get method. So when I run this example, you can see that product 50 was a success, 300 as well, and 200 too. But the product that is found was 50, and with 50 the shutdown method was called. And then I waited for the same. Let's try it again to show you. That will also stop a virtual thread. So what I now just did was I made product 300 return a little bit slower. So as you can see, product 50 was found, it was successful, 200 was successful as well, but 300 is unavailable, this thread was cancelled. So it didn't finish in time. So the pitfalls of not using structured concurrency really is that you have to do the joining, exceptions, timeouts all yourself. So the managing of those lifetimes is something you get out of the box with structured concurrency. And that makes it really nice if you have lots of virtual threads that all need to be managed. So all you need to get started with virtual threads are really just these 2 methods. The start virtual threads, which takes the runnable as a parameter, or the new virtual thread task executor to start working with virtual threads. So now it's time for questions. Yes? Sorry? No, there's nothing like that. You can use these scoped values if you want to return something back, or... Sorry? Go? Oh, in Go? I'm not that... Yeah.
So in Go, you have to add functions to give back the context to the carrier thread, because if you don't do that, if you put a loop that the coroutine, the same thing of a virtual thread, it never gives back the context, so it runs and it is never scheduled, never unmounted, right? If you talk about Java language. So in Java, do you need to do this kind of thing, or the JVM already does this automatically?
This product you mean, that from the last demo you mean?
Sorry?
I'm not really understanding the question.
Sorry. It probably does not happen in Java, because Go only gives the thread back to the carrier thread when it's sure that it can context switch. So it only does this during a function call. While the Java probably it does not. You do not need to have this, right?
No, you don't have to.
Okay. Because in Go, if you have a virtual thread with a loop, it will never give in no function call. It will run as a single threaded thing and not give the context back to the other threads, the other virtual threads.
Okay. Yeah, thanks. Yeah, I'm not that familiar with Go, so it's really hard to answer the question.
Yeah, sorry. I wanted to know because I use it to this. I have to put a lot of function calls. We can't have without function calls. But it's good to know that Java does not do this. Yeah. Thank you.
Yes?
I don't know if you know Quarkus, but we have small RAI framework that use uni and multi to create a synchronous task and so on. Reactive Quarkus is based on that. How we can compare this with virtual threads?
Sorry, no. Yeah, it's really hard to understand. Sorry.
You don't know small RAI uni or multi framework?
No, I'm not familiar with the framework, so that's.
Forget. Thank you.
I mentioned that virtual threads can be scheduled to different carrier threads. Does it cause any problems, considering that stack is in heap, not in
no, yeah, everything that is getting copied into the carrier thread will also be taken out of it. It will be just taken back into the heap, and then it will just.
No, I mean when you work with a virtual thread, it's just a fun fact. You don't need to take it into account that it can be scheduled to different.
No. It's all happened behind the scenes, all taken care of.
Okay.
So the whole blocking is.
There are some pitfalls related to this.
Sorry?
There are some hidden problems related to this fact. That virtual thread can be scheduled to different carrier threads.
No, just the. No, the only thing that happens if you have the thread local variables, because you're going to create lots of virtual threads, that also takes up a lot of memory. So that's when you want to use these scoped values, but I don't know if there are any issues with just frameworks and the whole scheduling on different carrier threads. It's all abstracted away for the developer.
If you use thread local, it will be local to virtual thread or to carrier thread.
Sorry?
If you use thread local, it will be local to virtual thread or to a carrier thread.
Sorry.
Thread local variable, it will be in virtual thread stack or in the carrier thread
the
stack.
thread local variable will still be in the virtual thread.
So it's also not a problem.
No, then you really want to use these scoped values.
Okay. Thank you.
So in case of you need to extract some thread dump for the memory, of course your application doesn't have problem, but if so, will be the virtual thread present on the thread dump from JVM?
I don't know, never tried.
It's a good question, man.
Yeah. It's a fair
All right.
Hello. First of all, thank you for the presentation. If I understood this correctly, carrier thread can be seen as a platform thread. So
yeah.
It includes all the costs it is involved in as a platform thread. Is there some sort of pooling for these threads as well to optimize? Is it done under the hood? Should we also take that concern into account?
Yeah, those carrier threads, they run in the fork join pool. So this fork join pool takes care of the whole scheduling and running part. So yeah, there were some plans in the beginning what I read from the mailing list is that they want to let developers create their own schedulers, but that's still talk for the future, and I hope they will somehow implement it, but
okay, but
not yet.
As a starting point, we don't need immediately to be worried about that. It's already kind of taking advantage of some pooling mechanism behind it.
Yeah, it's already taken care of, so you only have to just create the threads.
Thank you very much once again for the presentation.
Right. In your last example of the structured concurrency, what actually happens to the threads that do not finish? Do they get an interrupt or do they keep running? Because you were swallowing in your example the
they will get they will be interrupted if it supports the interruption. Depends. The sleep method does, but if you are doing, for example, a very long running calculation, just
so it might happen that the virtual thread keeps running.
Yeah, there is the case that it just keeps running, but it gets the signal. If it gets ignored, it's ignored. If it's
I was just wondering if it gets forcibly unmounted and just dies.
In a sleeping situation, yes, but that's,
Okay, thank you.
Hi. So thank you for the presentation. One of the things you said in the beginning was, I think we all agree, is that multi-threading application, debugging multi-threaded application, it's hard. With virtual threads, is there any advantage to debugging, or the process stays the same?
The benefit is that it works exactly the same as that you're used to it with the platform threads.
Okay, so it's basically
so that's the big benefit. That with the, for example, the async programming, it gets a little bit more difficult. But with the virtual threads, you get to write your code just like this. So that's the benefit, and then it makes debugging just a bit easier.
Okay, thank you.
Well, if there are no questions left, then thank you for attending.
everybody. How are you? Not tired? It's evening. Hope you're not so much tired. This is a light session. So we're going to talk today about code coverage. And before we do this, let me introduce my colleague, Margarita Nidzelska. She's staff software engineer at Sonar. She's also a Kotlin Google developer expert, so please welcome.
And I'm happy to introduce my colleague Evgeny, who is principal software engineer at Sonar. So we work at the same company. And he is also JCoco project co-lead. And he's going to be responsible for code coverage today.
Yes, so we both work at Sonar. Let's do a quick check. Do you use our products? Sonar Cube, Sonar Lint, Sonar Cloud? We hope you do.
Don't be shy. That's not a sin.
Don't be shy. You can like them, you can hate them. We don't really care today, because today this talk is not at all about these products. And whatever we are going to tell you today is just our own opinion.
And there is one more important thing you should know about me. I am from Ukraine. I was born and raised in Kyiv. And for almost all my life, I lived in Kyiv. And today, you probably heard that my country has huge troubles with our closest neighbors. And we need all the support that the world can give us. So if you feel like you want to support Ukrainians, here the QR code link to Trusted Charity Fund. Feel free to take pictures and scan it. And we really appreciate your help here. So the most important and the most serious part of the talk is done. Now let's have some fun.
Apparently today I'm going to be responsible for the fun part of this talk.
Then we all are doomed here.
Sorry.
So have you ever seen Mythbusters? Yeah, I remember when I was a kid, I really adored this show. When I was a little bit grown up and I saw the show again, it was not that funny anymore, but still interesting. So today, we're going to try to do the same. As you probably remember from the TV show, they tried to reproduce some circumstances of some common myth, common beliefs, and either confirm or dispel them. That's what we're going to do with the myth about code coverage. And what's our first myth? I'll let you pick up on.
Thank you. Let's maybe start with a simple, pretty simple question to the audience. What's your code coverage target, like percentage of the code which should be tested in your applications that you develop? Maybe 0? Who thinks that we should just ship into the production, no tests, nothing?
Who care about tests? Yeah.
Don't care about tests. I think it's a great approach, actually. So maybe 30? No? Higher? 60? Wow. 80? Oh, yeah, OK.
I'm curious from where they're taking this
The average is 80, that's 9. Maybe somebody is shooting for 100?
Yes.
It's a great value. What about 110?
Yeah, like 2 hands.
So I propose that our myth will be code coverage should be 100%. What do you think?
Yes, I agree. And I think it's even written in some books that code coverage should be 100%. And to me, and I think it's common belief that in the same words, you can say that if you can write one line of code, you can always test it. You can write one test that tests this line of code. So today, we are going to try to dispel or confirm this myth by using pair programming and ping pong. I'll be writing the code, and Evgeny will be writing tests for this code. Because I am a responsible developer, I prepared my part beforehand, and we have already my examples. Apparently, Evgeny is not, so he's going to write all the tests live today.
That's how principals do, right? They don't prepare. OK, so what you got here for me? A simple sum. No talk today happens without AI, so thank you. Copilot, I think I got a test.
Yeah, so 1 plus 2 is 3. I think I agree. Looks like you covered everything, so I expect 100%.
OK.
Yes?
Should we try?
Yeah, let's try to run them.
OK. So Let me...
Clean install, yes?
No, clean verify. Nobody today should use install. Even clean is not necessarily, but let's try. Build successful, test pass. Should I look at the coverage?
Yeah, let's look at the code coverage report. And as Evgeny is co-lead of JCoco, today we're going to use this tool, Java code coverage, and it shows us an interesting result. For some reason, it says like nothing is covered. Yes?
That's unbelievable.
Yeah, I think that's my mistake. Sorry, because I prepared the example. Let's check. Yes. You can see that the import of your test, of your annotation, is coming from org GUnit test, so it's GUnit 4.
What's wrong with GUnit 4?
Nothing is wrong with GUnit 4 if you're 10 years ago. But let's go and check our POM XML.
Okay. What do you expect to find here?
You can see that we have GUnit 4, but we also have GUnit 5. And which one is actually executed? Now, apparently, we tried to execute tests from GUnit 4 with GUnit 5 engine, which is possible, but to do so, we need to add the Vintage engine. Have you ever faced the problem like this? Have you ever forgotten to add Vintage engine in your life? Like in my company, I had a lot of situations like this with my colleagues. They always forget to add Vintage engine when they migrate from GUnit 4 to GUnit 5, and tests are not run. So what's going on? The coverage shows you which part of the code was executed. And because the test didn't run, nothing was executed. And
we could have debugged this, right? If you would just look at above, number of tests would be 0, right?
Yeah. Okay. So what we are trying to say here, we just faced our first myth that we dispelled, that zero code coverage is always bad. Why? Zero code coverage doesn't say, sometimes it doesn't say that you didn't cover something. Sometimes it says that your tests weren't executed. So in some situations, zero code coverage can help you debug and find the problems. For example, if you just saw the success and go ahead, you might not notice that your tests weren't executed. In our case, with zero code coverage, we understood that our tests weren't executed and fixed our problem. So in some situations, zero code coverage or lower code coverage is a debugging tool. So code coverage could be used as a debugging tool.
You know what? I just got an idea. Who is using Eclipse here? Other Eclipse users? Some? As you could see, I don't use Eclipse. I use IntelliJ, but in my life, it happened that I inherited some Eclipse project. Actually, I inherited maintenance of JCoco code coverage plugin for Eclipse called ECLEMMA. And I know nothing about Eclipse, but I have to maintain this thing. I know nothing about Eclipse and about this project code base, but I get some user report. And some user says, well, you know what? In Eclipse, when I hover over coverage S, I get some strange exceptions in my log and my console. And that's the report. How could I debug this? There is no breakpoint. I don't even know where to put the breakpoint. So what I could do, I could actually run this plugin in Eclipse with code coverage.
So you're going to debug Eclipse in Eclipse?
Yes. You can do the same with IntelliJ. You can debug IntelliJ from IntelliJ.
OK.
So Eclipse is starting. Here is my new Eclipse instance. It runs with code coverage enabled. Here is some example project. I could hover over this line. Yeah, you see that some exception, something happens, but none of those exceptions points on actually our plugin. So where to put the breakpoint, we still don't know. What we can do, in original instance, we could ask to dump code coverage results and to reset what we collected so far. Let's just do it one more time to see that it's 0. Yes, it's 0. And in this instance, we can do the action, like hover over, and ask for code coverage again. And what we are going to see in the code coverage result is exactly what was executed when I was performing the UI action. So this code was executed. So now I know that probably I put a breakpoint here.
Nice. So technically, you can use code coverage not just to measure the coverage, but also to find the way what was executed and use it as a debugging tool. So just another myth that code coverage is used solely to measure coverage is busted.
Yay.
Yeah, let's continue with our examples.
Okay.
I think I prepared something for you. Okay. So we've recently been to a few conferences, and this is actually our third conference in a row. It was KotlinConf, JPrime, now it's Jnation, and next week we are going to be in Barcelona for WCN. So we are at a stupid simple function to identify what is the best conference in the city, and city is enum.
And you don't want my life to be simple, right? There is 4 values. So.
Yes, I want you to write 4 tests. And I want you to make some copy-paste mistake, of course. Have any of you been to KotlinConf here? Who actually uses Kotlin? Just, you should use it, it's perfect language. I was not, but Evgeny, I was not allowed to speak about Kotlin at this talk because it's a Java talk, Java conference, but I'm Kotlin GDE, I have to, I cannot live without it. So are you ready with your tests?
I hope, yeah, I'm done. There is 4 enum values, so 4 assertions. Here is my test.
So I think you covered everything, yes?
I hope so.
At least I don't know what more to cover here. I expect 100%. Let's run the tests.
Okay. You're not tricking me with JUnit 4 anymore, right?
Yes, I hope we fixed it.
I think this time I use JUnit Jupyter, just to be sure. Okay.
So use JUnit 5. If you take one thing out of our talk, that you should use JUnit 5, not JUnit 4.
Yay, some coverage, but...
It doesn't say it's 100%. What's wrong with your tooling? Okay.
Come on, it's not my tooling. Come on, enum has 4 values. There is no way I could cover this default. Like it's not possible.
Come on, we put a statement in the beginning that if you can write 1 line of code, you can test it.
Okay.
And
what you would suggest?
I would suggest let's use mocks here.
Mocks?
Let's try to mock.
Okay.
I know you're a principal developer. Probably you'll never write mocks in your life.
But let me try. So I'm going to have my mock. What do I want? I want when I am asking for the best conference, then...
We need to test some default case.
The return default case is null, so I will return null when I'm asking for the best conference. And I'm going to do the assertion that I'm getting null when I ask for the best conference. Oh, there is refactoring. I can simplify the assertion. Here we go.
Yeah, let's run.
Okay.
Okay. So who thinks everything is covered now?
Sorry.
Oops.
What?
What's going on?
A demo effect.
Demo effect, yes.
Something is not quite
Something
right.
is not working. So apparently...
Let me try to do something.
It's principal developer writing mocks for the first time, so demo effect, let's forgive him.
What's going on?
Are you in the right folder?
Yes, but okay, let me maybe try like this.
Okay.
I'm doing the same action, hoping that Compiler will give up.
When I was the mock
You're
inside
trying to
before
stop
the,
final
I think
method.
you're,
Ta, 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 ta.
yes.
Sorry, Makita, do return now.
Best concurrence,
Yes.
yeah.
Yes. So
Yeah.
you see, I never
Yes.
write
Okay.
mocks, so I don't know how to do that. Should be better now.
Yep. Spot it. Yeah, like.
Thanks to the audience. Yay.
Yeah.
Build successful.
How many developers do we need to write mocks?
Okay. You know
And
what?
I think it still doesn't work.
It didn't help it. You know what? I heard this. I've read this even in Makito issue tracker. I think mocking doesn't work with code coverage. It's simply not possible.
Do you believe it? Do you believe that code coverage doesn't work with mocks?
Come on,
I think
I
the
have an
audience is
example.
tired. Yeah. Let me a little bit explain you what mock is, what you actually did. So when you mock something, it is not going to be executed. So what you did, you mocked the best conference function, and then you ask to execute it again on the mock. So you actually asked to return null instead of executing this function. You're not supposed to mock the function that you test. You need to mock the dependencies of this function. So this time, let's try to use mocking properly and mock enums.
Mock enum?
Yeah.
Are you crazy? Enum is final.
Do you think we can mock
you
enums
really
here?
mock enum? Okay, and when we are mocking enum, we really need to mock ordinal, I guess. That's about what is going to be used for the switch.
Have you ever mocked enums in your life, actually? I also don't know if it's going to work, but at least let's try.
Okay, let's see. Wow, that's crazy.
So
That's
it's
some
still
black
possible
magic.
we wrote one line of code, and then we can write test for it.
But that's black magic. Come on, enum is final. You're not supposed to be able to mock the finals.
But we have 100% now.
But hold on, let me try something, you know. I don't trust the black magic.
Okay.
And you know, black magic with GVM tends to be not supported in future GVM versions. So which Java version we use? 21. Let me try latest of
Early
the
access.
latest, like early access build of GVM.
Let's try 25.
25 doesn't exist. 23 early access, a couple of weeks ago, it was published. Can I try that one? Ooh, doesn't work.
So you see, mocking doesn't always
something
work.
crashed. Yeah, something crashed. So I really hate a magic behavior. So you know what? Even some people say this to us, that Jacoco should ignore this line. This would be great, but, well, if Jacoco can ignore this line, then probably compiler can also ignore this line. But you see, compiler tells us, well, the default is still needed to initialize X. To solve this problem, Java developers, you know what? They introduced switch expression. We have Java 21 in our project, even now 23. We can use modern features, switch expression. Can I refactor this?
Yeah, let's do.
Okay, so.
Does IntelliJ have such refactoring?
Not directly, but I think we can do like 5 hops and we got our switch expression. And now I think I don't need this black magic. And now I think I can just execute.
And do you think it's gonna run in Java 23?
Yes, I'm on Java 23, build successful. Let's look at the coverage.
Okay.
Oops. 100.
So you see, another takeaway, don't use switch statements if you can use switch expressions.
Okay, I think there is a better takeaway.
Yes, that we learned that code coverage actually works with mocks if you know how to write mocks.
Okay, should we move forward?
Yeah, I think I prepared another example for you. So this time a little bit less cases.
Thank you very much. Just 2 cases, right?
So here's a stupid, simple function to calculate the
You
perimeter.
learn it, yes. We can use modern features, select interfaces, records. Oh, you know switch expression, actually, but you didn't use it in the previous example. Fine. OK, what do you want to...
You're talking like my manager.
Yeah. What do we need to test here? We need to... You want to check whether I know how to compute perimeter.
Yeah, or maybe whether Copilot knows how to.
So let's do the perimeter of rectangle, and let's do the perimeter of...
Do you agree that's the right way to calculate it?
The square. That's fine.
Oh, looks like it. Okay. Let's test it.
Ouch.
Oops, something is not covered. You know what?
Hold on. Oh, can I look?
Yes.
Oh, there is some branches. That's weird. What would you suggest?
I don't know. Remember what we did last on the previous example?
We changed
we
Java
changed
version.
Java version.
Can I try to go back?
Yes, and looks like JCoco is not yet ready for that version.
Well, shit happens. Oh.
So you can see we changed, the only thing that we changed was Java version, and it broke the coverage. So if you thought that code coverage does not depend on compiler, you were wrong, because it still depends, and maybe, Evgeny, you can explain why?
Well, all the tools that today exist on the market, most of the tools that exist on the market, they work with the bytecode, the result of the compilation, not with the source code. And obviously, the result compilation depends on the compiler. So that's easy. If you want to know more, just watch one of my other talks.
Yeah. I hope you know how to write mocks there.
I don't write mocks, I already told you. Should we move forward?
Yeah, let's go.
Do you have examples?
But you'll fix this in JCoco, yes? Or
for the next Java version release, I will try to fix this thing.
You know, this talk is recorded. So.
Maybe I should, instead of giving talk, maybe I should go and do some fixes. This time, what do you want me? You want me, again, best conference in the world.
Yes, today we simplified a little bit the switch, only with 2 recent conferences.
G prime, Jnation.
And
there is switch expression. Yeah. Again, enum, 2 cases, but switch expression should be fine like this.
Yeah.
I think so.
I think so too.
Why we are focusing on the tools that I maintain? Maybe we should try some other tools.
Do you want to run it in IntelliJ coverage? Yeah, you know that in IntelliJ you also can run with code coverage.
But this is a different tool, right?
Yeah, but this is a different tool. This is not JCoco. This is the one prepared by JetBrains.
Yeah, look, this time, first shot, 100%. I am good.
Yeah. Perfect. And you also know, because we work at Sonar, Sonar can measure code coverage as well.
No, Sonar doesn't. Don't lie to people. Sonar doesn't measure code coverage.
Okay, Sonar
imports code coverage reports generated by JCoco.
Come on.
Yeah.
Why are you so smart?
So, should I try Sonar?
Yeah, let's try and look at Sonar.
You expect something different to be shown in Sonar?
Let's run. Don't talk too much. You know, we are not supposed to run NVN Sonar.
It's deprecated, but it still works. That's fine. I will migrate later, okay?
Because we plan to drop this in the upcoming releases.
So.
Yes, it's slow.
You are a developer of this tool, right? You should speed it up. Not for a live demo, come on. So, what do we have here? Let's look.
Code coverage.
Overall. I told you, 100.
Okay,
Yay.
So as you told us, Sonar imports reports from JCoco. So let's look at what JCoco says to us. Because if Sonar imports wrappers from JCoco, the two wrappers should be the same.
What?
So you see.
What?
And I think this is another myth that we just busted. Can you
Open
back
the
to
myth?
the presentation? Yes. That code coverage is the same in all tools. First of all, code coverage might be different between different engines, like IntelliJ Engine or JCoco. And another thing that it's also different between SonarEdge and JCoco while they're using the same wrapper. So this is because the different tools calculate coverage, calculate numbers differently. So you need to read the documentation to understand what is actually calculated.
So JCoco tells me that I am not covering something on this line. Oh, probably it's lambda, right?
Yes. And the fun part that JCoco is actually right here, because we never tested the exceptional path.
But it's kind of, again, not possible. But OK, this time I know that I can actually mock the dependency. In this case, the dependency is load conference, and I'm going to return optional empty. Should be fine.
Yep.
So, and we expect, oh, thank you, Copilot.
So generative AI works, yeah?
Yeah, should be good now.
Let's test.
Try. I'm not going to execute Sonar. We know that it gives us shitty result.
Come on. You work at that company.
I will open a ticket
So
to fix it.
now JCoco is happy. So everything is covered because we covered the exceptional path. But you know what? Since we are going into that direction, trying different tools, let's try another tool.
Which one?
Let's try p-test. Like, have you heard about mutation testing ever? So let's try to see what's going on mutation testing here.
Okay. Yeah, so if you haven't heard, there is a tool in GVM world called p-test. It's a mutation testing tool. What is mutation testing?
Actually, for those who haven't heard, mutation testing is another way of checking the coverage of your code by tests. So how it works? They introduce the change into your source code. Not into your test, but the source code. And then if after this change, all your tests passed, that means that this mutation survived, and your tests are not covering some part of your code. But if the tests fail, it means that this change affected your tests, and it means that your tests are good enough. So in our case, there was one change in our source code that still passed. Let's check what it was. So you replace the return value of the lambda with null, and it still was fine. So let's do it.
So p-test tells us that we can actually replace what? This with a null.
Yes.
That should be a null pointer exception. Come on, you cannot do this.
Yes, and...
oh, our test passed.
But our test passed.
What?
You know what?
How is that possible?
Because we are expecting the runtime exception. And you know, null pointer exception is also a runtime exception. So it's not enough just to check the runtime exception class. We need to check exactly by get class.
Oh, yeah, now better. Now it fails.
So now it fails.
So I can return the runtime exception, and we hope that p-test are going to be happy, right?
Yeah.
Where is my console? Let me try to get back my console.
Yeah.
p-test.
So p-test. Okay.
Yay,
Now
p-test
everything
now
is covered. But you know what?
What?
Let's try to change the error message.
Okay. Why? What you're trying to say is that even...
I'm trying to say that because we don't check here error messages, it still can fail. But mutation coverage didn't tell us that we are not testing the error message here.
Okay, so you are saying that this is the best test, right?
Yeah, so now we covered everything. So what we are trying to say, I think let's get back to our myth here, that first of all, line coverage is not enough. That's what we showed you when we said that Lambda was not covered in JCoco, but it was covered in IntelliJ and in Sonar. Then, when we saw 100% of code coverage, that was still not enough to say that our tests were good, because mutation coverage showed that something was not covered.
Okay, but even mutation.
And the fun part that even 100% of mutation coverage doesn't guarantee test quality and quality in general.
You know what? Our customer actually wanted to load this from database, and
Yes.
we are not testing this.
Because the point is that no tool can guarantee the quality of your software. Like, you can use them, they can help you to find some problems, but no tool can say you that your software works 100% correctly. Because like no software can know what are the requirements. That's why we still need people here.
Okay, so
or AI.
Speaking of quality, let's go back to the Sonar Cloud report. Here, our just written shiny project with 100% code coverage. And can we use this metric to compare projects? Can managers use this metric to say, well, this team developing this project performs much better than, let me pick another project, like
for example,
much better
JCoco.
than this project. Yes, it's actually JCoco itself. Look, code
So
coverage is not 100.
So you look, the JCoco tool that we are using to measure coverage doesn't have 100% of coverage itself.
Which project would you trust if you need to pick between these two? 100%
Of course this
coverage.
one, it's all green. Like.
Okay. Let's look at what is not covered in JCoco. I can show you one of examples, like what do we have here? Oh, that's our good old friend, Switch. Switch by Enum. And you know what? I don't want to cover this thing, like, sorry, but I'm not going to introduce a dependency on a mocking framework which can break with Java version upgrade. I can just ignore this, it's fine. And, well, sorry, I cannot use switch expressions here. We still need to be compatible with Java 5.
Is that because of your manager?
No, no, it's because of our users.
So, yeah, what we are trying to say here, that code coverage is a developer metric. You can or you cannot show it to managers, but you cannot use it to compare the project, to compare the velocity of the team or how good is the team, because it's just a number. It says nothing about the quality of the project, and it should not be used to compare the different projects and to tell what to do. And you might probably notice that we did stupid things just to reach 100%. We introduced mocks where we had to be binded to some Java version. We introduced some stupid tests that we didn't need just for the sake of reaching 100%. So code coverage is not for managers.
Okay, are we done?
No, I think there is one more thing that we need to discuss here, because so far we've been focused on the correctness and on the code coverage itself, but we are developers. We love physics, and in quantum physics there is a concept, and there is.
We are developers. We love physics. Yeah.
Don't you?
We are engineers, and engineers love physics.
Okay.
Yeah, I love physics.
So, and you know, in quantum physics there is an observer effect. It tells us that the fact that we are observing something might change the observable. And I'm curious, the fact that we are measuring code coverage, does it affect something, for example, performance?
This time I prepared something for you. This time I came prepared.
So you have a benchmark?
I have a benchmark. Let's look at the benchmark. So, what do we have here? I have a simple, stupid Fibonacci numbers calculator, like this. We pass a number, and we get a Fibonacci number at this index. I'm not going to write assertions for these tests. I hope you will trust me that this is a Fibonacci number calculator. That's not really important whether this code is correct or not. We want to look at the performance. I'm going to use GMH, Java Micro Benchmark Harness, to measure multiple things. There is a little bit of magic you're not interested in, but, well, we are going to take the original class. Here is original. We are going to instrument it using Jacoco, and we are going to instrument it using JetBrains coverage engine, the same that we can see on the default settings in IntelliJ IDEA. And we are going to run this using GMH and measure what it takes. By the way, I'd better already run and then explain what is happening, because it's going to take a while. So we're going to measure nothing. Like, it's going to be our baseline to see that our measurements, they make any sense. Then we're going to measure how long it takes to compute Fibonacci number without any coverage measurement. And then we're going to measure what it takes with Jacoco and what it takes with JetBrains coverage engine. So 50% complete. I should have executed it at the beginning.
You should have executed it beforehand.
Yeah, sorry.
But we still have 13 minutes. Will it finish in 13 minutes?
75%.
Yeah, okay.
Good on track.
So I think I know people who develop GMH.
Okay, so here is our result. What we can see here, well, no operation takes some time because we're probably measuring the GMH infrastructure. So measurement affects what we measure. It's not a no operation. Then we can see that computation of Fibonacci number is obviously slower than no operation. That's what we expect. Seems that our benchmark makes sense. Then we have Jacoco. Well, it's a bit slower than the original. And then we see JetBrains coverage engine. Wow, that's like 4 times slower than the original. So yes, I think measuring code coverage does affect performance of the application. Look at the numbers.
JetBrains is what is executed when you do it in your IDs.
Yeah, I think we should change the settings in the IDs. I think there is some setting to switch to Jacoco.
You see, if you try to execute the code coverage through IDE, you need to understand that there is some performance cost here.
Well, even from the command line, there is some performance cost.
Yeah.
And you know what? I even heard some stories where people were executing code coverage in their production system.
By mistake?
Understand, no, not by mistake. They wanted to understand which code is not touched by users to delete it, unused code. And actually, well, this is just a micro benchmark. Your melange may vary from use case to the use case. Those guys, they're not dumb. They were not doing this by mistake. They did a proper measurement, and they found out that in their case, in their production system, the overhead was far less than 1%. And this was acceptable for them.
So, like, yeah, even if we look at our benchmark, it still depends on your code, how big is an impact, but there is definitely some impact.
Okay.
So,
should we move on?
Yeah, let's move on.
What?
I think we talked about the performance, but performance is one thing. But the program that we are actually executed, is it still correct when we introduce code coverage on the program? Do we actually change the program itself?
I came prepared again. I have another example for you guys. So, in the Java virtual machine specification, there is an interesting property, structured locking. Structured locking is a situation when, during a method invocation, every exit on a given monitor matches a preceding entry on that monitor. This property requires cooperation between Java virtual machine and the compiler. And this property is perfectly satisfied by the Java compiler. It's not going to be broken. Then developers of code coverage tools like JetBrains, Jacoco, etc., they learned the patterns that compiler produce, and they adopted to those patterns. So by instrumenting the compiler-generated code, we do not break this property. And we developed those tools for the Java compiler. And then, bam, surprise, we got some non-Java languages running on the GVM. For example, Groovy. And then, bam, another surprise. We actually got man in the middle between the compiler and code coverage measurement, there might be another tool. Like Android developers know this tool very well. There is R8 shrinker that is going to shrink your bytecode to be able to run on the Android device. And those tools, or Groovy compiler, unfortunately, they generate a pretty weird bytecode, which after instrumentation by code coverage tools are going to be with a broken property, with this property broken. To show this, well, I need to generate some bytecode. It's not important, but what is important is that we are going to run this bytecode non-instrumented and instrumented by Jacoco. And we are going to look on whether this property obeyed or not, so we are going to ask for the monitor mismatches. And we are going to ask GVM to do JIT compilation of this bytecode. Let's try. And here is what we are going to see. When we run original, there is no error message from GVM, from JIT compiler. And when we run instrumented, unfortunately, we are going to see the warning, monitor mismatch in the method. This warning means on the hotspot GVM that, well, these methods are never going to be JIT compiled. We broke the property that prevents JIT compilation of this method.
But it doesn't break the application, it just affects the performance.
Hotspot GVM is pretty good. Hotspot GVM says, OK, this property is broken, then we should execute this method in the interpreter mode, and then this property will not be broken. Unfortunately, Android runtime is much stricter than that. On Android, when you break this property, your entire application is not going to work.
Okay.
So, well, yes, there is a bugs in code coverage tools which can change the behavior of your application.
Okay, so I think we just got to another myth that measuring on coverage affects your application, so you should keep it in mind. So,
let's go back to the myth number one. What do you think?
Should code coverage be 100%? Are you tired? Yeah.
Well, no.
I hope we proved today that code coverage should not and cannot be 100%. Code coverage should be at the level when everything that is supposed to be covered is covered. And I know that it's much harder than to have some number target, but this is the way to go. In ideal world, it should be 100%. But in the reality, we cannot have 100%, and maybe there is some way for improvement on the tooling side. Maybe we need some way to accept or won't fix code coverage misses in tools like Jacoco, probably in Sonar, or in the way how we show code coverage.
You're again trying to finger point on Jacoco and tell me that I should go and implement some feature, right?
No, I'm just saying an idea.
Let me ask you a question. Every time we introduce a thing like this, accept or won't fix, what happens on the next day? Who tests the tester? Who monitors? Who guards the guard? The next day, managers are going to come and ask you, you know what? We want to track the metric of won't fix.
As I said, we are all doomed here. So, code coverage should be 100%, busted. So there is some short summary that we want you to take from this presentation. First of all, code coverage is a developer metric. Don't use it to think about the quality of the project and not show it to your managers. Tools are not ideal. You might see that tools depend on compiler, tools depend on different things, and there are some compiler artifacts, and tools are different. So we cannot trust them completely, but tools are still helpful. So even when something is not covered, and even if it's a false positive or if it's a mistake, it's still interesting to dig in to find out why, and maybe you'll find some bugs on your side anyway. So don't try to please the tools. Don't try to reach 100% just for the sake of 100%, but use them smartly and try to cover what is not covered for your application. So
we hope you enjoy it.
This is it.
Thank
you for attending.
And I think we have like 5 minutes. If you have some questions, we can take them. Otherwise, we will just make a photo.
Yeah. Yep.
If you are shy to ask questions now, you can catch us outside and we will talk about whatever you want.